Why learn Python? Well, there's several reasons. First of all, it's the most popular programming language by many metrics. Of course, not everyone's going to agree with that, but the TOB index, a popularity ranking of programming languages, has Python at the number one spot, and it's not even close. C++ comes in second, 8 percentage points behind. Python gained that first spot in these rankings in October of 2021. So it just continues to gain momentum, especially with the advent of more widespread AI that we can use. Python is one of the things that underlies all that AI demand. So very popular. Another website, PyPol, also lists Python as number one. Again, not even close as the most popular programming language. So many different metrics indicate that Python is a very important language to know. If we don't learn Python, we may be missing out on a lot of great stuff and a lot of powerful things that Python has to offer. So there's also a very large community developing Python, and it just continues to gain steam and momentum. Python developers and people who know Python also tend to have a high salary and high demand in the job market. Python will make you a more valuable employee, undoubtedly. It's also very versatile. It's great for things such as data analytics, machine learning, web development, and scripting. It's wonderful for automation and working on hobbies. And many professions, even outside of tech, can leverage Python to bolster their power with their job, to bolster their competency and be able to perform their job even better. Python is also easier to learn than a lot of other languages. It's less code and more user-friendly, arguably, than something like C or C++ or Java. So it's a great language to start with if this is your first time learning Python. And of course, it's important to know that different languages are optimized for different things. So just because Python's very popular does not mean it's going to be the best language for every use case. But that said, it is the best language for a lot of use cases. As we see, as I mentioned earlier, with the advent of common AI and other things, it's continuing to explode in popularity and usefulness. So many good reasons to learn Python. And I imagine some of these reasons are why you're here. And I'm so glad you're joining in this endeavor. Undoubtedly, you're wondering if this is the right course for you. So I wanted to highlight that and talk about a few use cases of where this course may be valuable for you. So I think that it breaks down into four main categories where you will find value in this course. I promise you, if you fall into one of these categories. If you have no familiarity with coding at all, but you want to start with an easy to learn, powerful language, that's Python, then this course will be valuable for you. If you're a beginner Python programmer, you have some experience, but not a lot, and you want to take your coding to the intermediate level, this course will add value for you. If you're an intermediate Python programmer, perhaps several years of programming experience in Python, but you want to solidify and refresh your skills, perhaps you want to round out some skill sets with Python, then this course will add value for you. Or if you're a beginner to advanced level programmer in any other language, but you want to learn or refresh Python skills, then this course will be valuable for you. This course will not take you to an expert level of Python development. That will take years of programming. And I also do not cover all of the many advanced topics in Python. So it's more focused on beginner to intermediate level, which, that said, a beginner to intermediate level Python developer or person with these beginner to intermediate level skills in Python can do a lot of powerful things in their career, at their job, at home, with hobbies. You will be able to do a lot of things as a beginner to intermediate level Python programmer. Some common job titles for people with Python skills that I think is worth highlighting are listed below. I won't read those out for you. Personally, I'm currently a network engineer. And that's one of those things. I work with switches and routers and firewalls and load balancers and all that kind of stuff. You may not be inclined to think that a person like me would use Python, but I'm telling you that it is everywhere. It is ubiquitous. And the fact that I know Python to a good level helps me tremendously as a network engineer. So if you fall into one of these categories, this course is for you. You're in the right place. I think you'll definitely find some value to it. Okay, guys, let's get right into it with what I like to call the 3 S's of Python: setup, syntax, and style. We're going to set up your Python installation so you can write and run Python code. We're going to talk through the syntax of Python, which will enable you to write Python code that actually works. And we're also going to talk about the style of Python. In other words, writing Python code that's easily readable and clean. So let's get started. First things first with setting up the environment. We're going to download and install Python. And to do so, we will just simply visit python.org, hover over the downloads section, and download the recommended version for PC or Mac. Run the file, and that will start the installer. And one note for PC is that we want to check the box, add Python to path. That essentially is like creating a shortcut to make it easier to run Python. And in Mac, that's already done for us. We'll then just keep the defaults and continue through the installer, and then verify the installation with a few commands. Okay, this is how to install Python on a Windows computer. I've navigated to python.org. Let's hover over the Downloads tab, and it detects that I'm on a Windows computer. This is the latest Python version. We'll click on that. It may be a different version for you, depending on when you're installing this. And as we install that, we see the files downloaded. We'll click on that, and it's going to start the installation. Now, one thing that's important is that we click add python.exe to path, which will make running Python programs easier. And we're just going to click through install now. If you want to change the location of your Python install, you can do so with a custom installation. And we'll click install now and go through that installation. Okay, I fast forwarded through that. It only took about 30 seconds, pretty quick. Now we're done with the installation and we can close this. And on to verifying that Python installed correctly. So first of all, let's open up command prompt. And we can type Python --version. If a version shows up, that means Python is installed. We can also type pip3 --version. And if a version shows up, pip is installed. That's the Python package manager, which we need. And we can also open up a program called idle, which is a Python IDE that's just out of the box and we can use very quickly for developing Python. We see we can run programs in there in Python, and also we can just type Python here at command prompt and run Python code here as well. So we now know that our Python installation was successful on a Windows computer, and we're ready to go. Okay, guys, let's get right into it with what I like to call the 3 S's of Python: setup, syntax, and style. We're going to set up your Python installation so you can write and run Python code. We're going to talk through the syntax of Python, which will enable you to write Python code that actually works. And we're also going to talk about the style of Python. In other words, writing Python code that's easily readable and clean. So let's get started. First things first with setting up the environment. We're going to download and install Python. And to do so, we will just simply visit python.org, hover over the downloads section, and download the recommended version for PC or Mac. Run the file, and that will start the installer. And one note for PC is that we want to check the box add Python to path. That essentially is like creating a shortcut to make it easier to run Python. And in Mac, that's already done for us. We'll then just keep the defaults and continue through the installer, and then verify the installation with a few commands. So let's start that installation process on a Mac. So we open up a web browser, go to python.org, and hover over the downloads section. It already understands I'm on a Mac computer, so it's showing me the download for that. We'll click this downloader and save it. That downloads quickly for me. We'll then open it up by clicking on that download. Continue, and just continue and agree through the defaults here. And it will take 176 megabytes of space. We'll install. Okay. And this doesn't take too long, so we'll just keep you here while this is installing. Okay, it opened up this folder for us showing some README data for Python. And hey, we're done. We'll close that, move the installer to the trash. And as we saw, we want to run a few verification commands. So we're going to run python -- version to check the Python version. We're going to run pip3 -- version, which is a package manager installer for Python and helps us do powerful things with Python. And we're going to check idle3, which is a GUI or an interface that makes it easier to develop in Python from the get-go. So let's run those commands by opening up terminal. Python -- version. I have another Python installation here, so that's why it's showing me 3.11, but for you it will probably show 3.12 or something newer. We can do pip3 -- version. That shows that it's indeed installed and it's coming up with a version there. Again, that's for the Python package manager. And we can do idle3. That opens up what's called idle, which is, again, like a GUI for Python. We can run commands in here. The Python command, and it prints that out to the screen. We'll exit from that. And we could also just type Python here and type things, and we're literally running Python now. So we know our Python installation was successful. Let's now move over and do the installation for a PC. Okay, we are now on a Windows computer. We've navigated our web browser to python.org. Let's hover over the Downloads tab, and we see it recognizes we're on a Windows computer, so it will give us the Windows installer. We'll then download the latest version. For me right now, at the time of this recording, it's Python 3.12. It may be something different for you. So we'll click on that and save it. And once the download is completed, let's open that up. And remember, add python.exe to path. And that's, again, essentially like adding a shortcut to make running Python scripts easier for us. So we'll just click install now. It will install to this location. If you want to change that location, you can under custom installation. But for simplicity, I'm just going to click install now. And this will take 30 seconds or so. It may be a bit quicker for you or a bit slower, but overall, not a very long process to install Python. We'll just wait for it here. Okay, it's completed. So now we need to do some verification, and let's just open up command prompt by typing cmd in this finder down here and clicking on command prompt, and we can run our validation commands. Python -- version. We see it's Python 3.12. Pip 3 -- version. And we show a version there, so we know we're installed. Now, if we try to type idle 3 on Windows, it's not recognized because that's not added to our path by default, but we can just search here for idle and click on idle. And that will open up idle, which again is like a GUI for Python, or makes it a little easier to develop if we want to use it. We see we can run Python commands from there. Again, also just straight from command prompt, we can type Python code and run it by just typing Python. And we see that works. So we are now installed with Python on Windows and Mac computers, and we can write Python scripts and execute Python code. Okay, now that we have Python successfully installed and running, we're going to write our first program using what's called REPL, which stands for read, evaluate, print, and loop. And all this means, as we look at as an example here, is that we can write code on each line, and the Python interpreter will execute that code as we write it in, and it's an easy place to test code and write code snippets and to practice Python. So we can use this REPL interpreter with idle, or also just by typing Python at the terminal or at command prompt if you're on Windows. So let's go over to idle right now. And again, this can be opened with command space on a Mac, typing idle, or finding the icon in the taskbar. On a Windows machine, we can search idle in the list of programs and open it up that way. And again, if we're in a terminal or at command prompt on Windows, we can just type Python, and that will also get us into REPL here. You see these three arrows, these three carets indicate that we are in the Python REPL, ready to enter commands and enter Python code. So first of all, we're going to create a story here, and let's add some variables. So let's put our name equals quotations, and then insert your name there. These quotations mean that's a string, and we'll get more into that in a bit. Then let's add our age. No quotations around that. because we want that to be represented as a number. And let's also put a place, just any place. I'm going to put a forest. And favorite food, let's say ice cream. I like ice cream. And lastly, let's put a thing here. I'm going to say sword. And all these are in quotes because they're strings. Now I'm going to paste this in, but feel free to pause the video and copy that or something similar to make your story. And what we're doing here is we're creating a new variable called story, and we're assigning it to an F string. That's the letter F, 3 double quotes in a row, and then text, and 3 double quotes to end. And this represents a text string, an F string, where each word that's enclosed with curly braces, as we see here, we see that's enclosed with these curly braces, is representing one of our variables. So it's going to replace the word in curly braces with our actual value for the variable for all of these. So now the fun part is we can print that story and see what happens. We're printing this variable story, which holds this F string. All right, so let's hit enter. And there we go. Once upon a time, Joseph was walking along in a forest eating ice cream. I could work on my grammar there. That's okay. Joseph suddenly found a sword. Then appeared 35 orcs. Joseph then defeated all of the orcs with the sword. Hooray for Joseph. So you can see here, if you are older, you get more orcs. If you're younger, you get less orcs. And that, my friends, is just a simple example of what we can do with Python and F strings and variables, and how we can use REPL, or this Python prompt here, either in idle or, as we saw, at the terminal or a command prompt on Windows. And we can run simple Python code and practice. And we're going to be using this a lot early on in this course, so we'll get familiar with it. And anyway, that was the first program I wanted to introduce you to, and good work, and we'll see you in the next video. Let's talk about syntax of Python. And what I mean by syntax is, you can think of it like the grammar of the Python language. It doesn't make sense to the Python interpreter to write code that is not grammatically correct or not syntactically correct according to Python. And so it will cause errors. It will break the code. It will not work. So that's what I mean by syntax. There's 5 things I want you to know with regards to syntax. And number 1, as we just mentioned, was syntax will cause errors. Syntax issues will cause errors. Number 2, indentation is important in Python. In some languages like C++ or Java or others, it doesn't matter how you indent, besides that it looks cleaner. The code will still understand it. In Python, indentation, if not done appropriately according to how Python likes it to be done, will break things. So indentation is important. And every time we see a colon or run into certain blocks of code, which we'll get into later, and there's a few more scenarios, we need to indent. It's just the grammar of Python. So remember, indentation is important. Thirdly, comments is a syntactical component of Python, and we can make comments with a hashtag, as it's sometimes referred to, or the pound symbol, or triple quotes. And these are lines of text that are not interpreted by Python. It essentially will ignore it. It's only for humans to read, for the most part. So comments can be done that way. That's a syntactical part of Python. Another big syntax thing is one statement per line. You can't do more than one thing on a line, usually. And keywords, there are certain keywords that have special meaning, and they can't be assigned otherwise. So we could not assign any of these as a variable name. We could not put them in the code anywhere. Yeah, because Python will look for these words and try to do certain things when it sees them. So those are reserved keywords. So those are the 5 important points that I want you to know about syntax as an overview. And here are a few examples. We've got some bad examples on the left and some good examples on the right. Here over on the left, and I'm running these in an IDE called PyCharm, and I've screenshotted them, and we will actually use PyCharm later on in this course. But it does a great job at highlighting for us syntax errors and telling us what they are. So that's why I've done those screenshots here. So this first example, we see we don't have an indented area on the next line after this colon, after this if statement. We need to have indentation, as we see here. That's one of those rules of Python, part of the grammar of Python. This next example, we cannot do more than one thing generally on the same line. So here we're trying to assign this variable and we're trying to assign this other variable on the same line. And Python doesn't like that. It's expecting the end of that line. So we can assign those variables on 2 different lines, as we see there. Now, also, another indent issue with another grammar part of Python, which is called a while loop. It's expecting an indent, as we see here. So just remember, indentation is important. So if we indent that, we don't get any issues. And I'm showing an example of the a keyword trying to be assigned and throwing an error, whereas we need to just come up with another name. We can't use that false name in our variable. Let's just look at one syntax error in Python. If we are expecting an indentation, so we can say if x, we'll create a variable called x, assign it to the value of 5. If x is greater than 5, print yes, just something simple, and then we'll hit enter again. Okay, x is not greater than 5, so it does not print yes. If x is greater than 5, now what if we have no spaces here, no indentation? Python cannot work with that because we're disobeying the grammar of Python. Let me show you an example of a comment. If we add that hashtag or pound symbol, and we can type whatever we want. It does not have to obey any rules with Python because Python, the interpreter, ignores it. Okay, so that did not throw an error, and we can continue writing our code. Same with triple quotes. This is just a way to have multiple lines of comment, and then we end it with triple quotes. And it just with idle, it prints that out, but it's not actually it's not actually doing anything. It's just showing that for our benefit. And one comment is that if we have these triple quotes assigned to a variable, like we did with story earlier on, then it then interprets that as a string. So differences between a multi-line comment and a string is that a multi-line comment is not assigned to a variable. And that's how we know that it's a comment and not a string. So there's a few notes for you on syntax of Python. Now that we've talked about syntax, let's talk about style. Remember our metaphor. Syntax is like the grammar of Python, and it will cause issues if the grammar rules are not followed. Style, following that same metaphor, would be like the writing style. In other words, the personality of our code. And it will not cause errors, but it does affect readability and standardization. So it's important that we follow also the guidelines for writing Python in order to write good code. PEP 8 is the official style guide for Python. PEP 8, remember that. And they have a website which overviews the style guide, and I have pulled that up over here. There's a lot to it. I encourage you at some point in your Python journey to read this at least once. I would not encourage you to read this now, but it talks about things like naming conventions, or when to use commas, white space, tabs or spaces, etc. All sorts of things to follow the appropriate style of Python and standardization. So one thing that really helps with learning PEP 8 and the style that should be followed for Python is using an IDE and a development environment like PyCharm, which we'll get into later in the course, because it highlights your code to help you follow PEP 8. So that's one advantage of using an IDE. And their guide, this is a guide, not rules, but it's accepted practice to follow. I'm going to share a few of the major highlights, in my opinion, of PEP 8 that are worth remembering, but I want you to don't worry about remembering all these right now, but come back to this later for reference. And with repetition, it will stick. So first of all, we talked about spaces with Python syntax, and indentation, rather. Well, PEP 8 recommends spaces, not tabs, for that indentation. They recommend 4 spaces where indentation is needed. One reason for that is that in different code editors or text editors, if you use a tab, it may not represent the same number of spaces as a different text editor. So if it's copied and pasted or opened by another programmer, it may look different. And we can make sure that our text editors and IDEs like PyCharm use 4 spaces every time we hit tab, so that we don't have to hit 4 keystrokes of the space to get the appropriate indentation. We can just hit tab, but in reality, it's spaces. So that's something we'll get to. Also, PEP 8 recommends 79 characters per line maximum. Again, in PyCharm, it shows you a line for the cutoff where 79 characters is, and it just helps. So IDEs really help with following PEP 8. Comment your code, that's important. PEP 8 really suggests that. There's some suggestions around blank lines and how they separate logical points of code. So instead of having just every single line filled with writing, it's good to have blank lines in between where needed. And imports at the top of the file, we'll get to that later. Quotes, we can use single or double quotes, but be consistent. So we see here we have a single quote around hello, this string, or a double quote around hello. They both work. They won't throw syntax errors. And you can use both, and I've seen both. Just be consistent with whichever one you choose. So let's go over here as an example. Print hello. That prints hello. Now, if we use double quotes instead of single quotes, it also prints hello. It does the exact same thing. So not a syntax issue. It's just style. And pick one and stick with it, and you'll learn what you prefer over time. Also, when we're using multi-line comments, let's not use single quotes like this. So we wouldn't use 3 single quotes. We'd use 3 double quotes for multi-line comments. And doc strings, which we'll get to, also suggest double quotes instead of single quotes. Don't worry too much about that now. Again, as you go through the course, come back to this slide, come back to this section and review this, and it will solidify it for you. White space is good to use for clarity to separate operators and operands. For example, 5 space plus space 3 instead of 5 plus 3. But avoid white space in between, like between the parentheses and the 3, or between a bracket and a letter, a character. And avoid trailing white space at the end of lines. Also, 1 space after a comma is recommended. This is a space character here instead of no spaces. So keep that in mind. Space after the hashtag and a comment in a single line. And naming conventions use snake case for function and variable names. Snake case is where, when we're naming a variable, we separate words within the variable with an underscore. If we have a variable with multiple words, like my name, we separate it with an underscore as opposed to my name. Again, they both work, but snake case, this one with the underscore, is preferred and more appropriate style. And we'll get into some Pascal case for class names and uppercase for constants later on in the course. Don't use single character name variable names like a letter, except for very short blocks, like loops or things like that. And lastly, aim for clarity over brevity. As you're writing code, just think, make it simple, make it clear, and that will usually lead you down the right path. So those are some notes around Python style. In this next section, we'll be talking about data types in Python. And to start off, let's do a little introduction. So first of all, let's talk about variables and how they relate to data types. So in real life, we assign variables to things. We assign value to something. And we store that in our memory, and we use that to make decisions and to reference. And computers are the same way. They store these variables or parameters containing values in their memory, and they reference them, and they can use them to make decisions. So, for example, in the real world, our friend's name might be Jack. And so that person's name, the name is the variable in this instance, is Jack. And the type of Jack is a string. And that's a Python thing. That's what I mean by string here. That's the data type. Whereas we might say, oh, the temperature is 40.1 or the speed is 60. And we see these have different types according to Python. Also, in our own mind, we might say, yeah, we know that these have different types, even though we don't talk about it like that, because we know we can add numbers together and numbers go up and down. Whereas names, we don't really add names together, right? I guess you could say, sure, we add a first and a last name and a middle name sometimes, or other names, but we're not combining the names like we are numbers. So we know we can do different things with numbers than we can with strings or these other values. So in real life, we might also see a light color, like a stoplight, and say the light is green or the light is red. And we make decisions based on what the light color is. We might also see a light switch and say the light is on or off. That would be a Boolean according to Python, on or off. As computers see this, a 1 or a 0. We also look at that as true or false. And these are different types in Python. If we want to have multiple things that we're referencing with one variable or one name, if you will, we can use a list type in Python and add multiple values to that list. Or we can describe data in a different way and have a dictionary in Python. For example, a phone number of a person might be this, and we might describe other data about this person. So we do this all the time in the real world, and we see these different data types. We know we can do different things with numbers and strings, and we work with that. Well, programming languages do the same thing. They need to know what type a variable is, and they need to know the value of the variable, and we can then do things with that, and Python knows how to work with that data. We could also compare this to types of vehicles with our Python data types. For example, we may have a train, and we know that the train carries a lot of passengers. It can carry a lot of passengers. It might also be empty, right? We know the train is constrained to riding on the tracks. It can't just go drive around on a road. Whereas a dump truck, that does not carry passengers, right? It's a different type of vehicle. It's meant for carrying dirt or rocks. It can definitely go off-road, off-track. And so we see these different types of vehicles, and Python does the same thing. It assigns data different types, and it knows it can do different things with these different types, different data types, and different variables that we have. So some of the data types we'll talk about are numbers. And there's two types of numbers in Python. We'll get more into this, but if we think, I have 5 apples, right? The 5, that's a number. Or 1.2 liters of water, that's a number. A string, that's another data type we'll talk about. That's arranged text, simply. And it's always surrounded by quotes. So when we have variables and so here's my variable, my string, that's the variable name. And the value of the variable is hello. It's surrounded by quotes. Whenever we see text surrounded by quotes assigned to a variable, that's a string. And Python knows the different operations it can do with a string. We also have a list that we'll talk about, which is an ordered collection of items, and they can be different types. If we have my list, we can have an apple, an integer, number 1, another string here, a Boolean, true or false, another string. Apple will always be the first item in this list. It's ordered, but we can, unless we change that, but it's a collection of items. We also can have a dictionary. This is another data type we'll talk about. That's a collection of key value pairs where we might be describing a lot of different things about an object, about something. For example, let's describe the apple. Well, the color is red. And then we have this comma here that separates to the next thing. Well, the quantity of the apples that we have in stock in our store, let's say we have 50 apples, and the price of each apple is 6.5. So that's a dictionary. We'll get more into that as well. And we also have a Boolean. This is the last data type we'll spend time with early on in the course. And that, as I mentioned, is true or false. like a light switch on or off. Or if we had a variable in stock is true for our store, for example. And last thing I want to touch on here in our introduction to data types is that Python uses dynamic typing, which means we don't have to explicitly define the type, and the types can often be changed. A lot of programming languages, you need to define the type of a variable as you write the code to create that variable. In Python, you don't. It assumes type. And I'll show you an example of that here in a second. We can also do something called typecasting, which is converting between types. For example, we can make a number into a string and vice versa, as we see here. So let's go over to idle, and let's create a variable called my number and assign that the value of 5. And let's see what type that is. Remember, we have this type command. We just put our variable inside the parentheses here, my number. It will show us Python understands this to be an integer. That's what int means here. Now, what if we do my other variable? Okay, and we assign that to a value of quotation, double quote, 5. Remember what happens when we put quotes around a value and assign it a variable? That is a string. So if we type my other variable, this should be a string, right? And indeed it is. Python sees that as a string. It uses this dynamic typing. We don't have to explicitly say this is a string. Python understands it to be a string because of the way we've defined the variable with these quotes. Now, what if we try to say my number 2, or let's make it more clear, my other number equals blah? Is it going to work? Python would have to understand this, right, as a number or a string, but we don't have quotes, so Python can't say that it's a string. So we think, well, will it try to make it a number? Well, that throws a syntax error. That throws an error, and it's like, well, I don't know what to do with that because you're not following my rules in defining variables. It's not a string because it doesn't have these quotes around it. It's not a number because blah is not a number, clearly. So there's just a simple demonstration of converting between types, numbers and strings specifically, and how we can define variables, the whole data, and how Python understands and interprets that in order to do stuff. Let's talk about numbers in Python. And we're going to learn how we can work with them. First of all, there are two primary types of numbers that Python works with and understands and makes a distinction with. In other words, it views integers differently than floats. These are the two types we're going to talk about. For example, it may allocate different memory for an integer versus a float. So it depends on the level of precision you need. But again, Python will automatically detect the type based on how you define a variable. Same way that we saw earlier in the course with strings and integers. If we have quotes around a variable value, it detects it as a string. If we, in the same sense, with integers, those are whole numbers. In other words, 0, 1, 2, 3, 4, 5, even negative numbers, negative 1, 2, 3, 4, 5, negative 10, etc. And so if we create a variable called myInteger and assign it a value of 1, that is a whole number. So Python will define that as type int, integer. A float, on the other hand, is any fractional number or rational number that has a decimal in it. That's one way we can see that in most cases this is a way to see that a number is going to be a float, is if it has a decimal. So my float equals 1.0. It's the same value. 1 and 1.0 is the exact same value, right? However, Python views those as different types because this float, has a decimal. And lastly, and we'll show some examples here, results of operations involving an integer and a float will be a float. So if we have my integer and my float, my integer plus my float, it will be of type float. So let's show some examples here. My integer equals, let's just say my integer equals 5. And then if we look at the type of my integer, that is an int, right? So Python auto detects that it's an integer because there's no decimal. There's also no quotes around this. It's a whole number. So it's not a float. It's not a string. It's an int. Now, if we define my floats, let's say 2.0. So we have a decimal here. Type my float. What is the type of my float, that variable? It is type float, as we expected, because there's a decimal there. Now, if to conclude this segment, if we create another variable, let's call it result, and assign it the value of my integer plus my float, so 5 plus 2.0, as we learned by checking the type, that will be a float. Adding an integer or any operation involving an integer and a float will result in a float. We'll now discuss some of the cool things that we can do in Python with our numbers. So this, first of all, this web page for the Python docs is very useful for understanding functions and operations around numbers. So I've pulled that up over here on another screen. And over here, if we look at numeric types, this is, again, just the Python documentation. And I've scrolled down here just slightly, and this is what I've included in the screenshot in the PowerPoint. It describes how we can manipulate our numbers and combine them in certain ways or do mathematical operations. And I invite you to take a look at that documentation whenever it's convenient for you. So let's try out a few of these. We see we can do addition, subtraction, multiplication, division, various other things. We're going to highlight this remainder as well. So x mod, that's what this is called with these operations, is mod, or modulus. So x mod y would give us the remainder of x divided by y, and we'll show you what that means, but that can be very handy. Absolute value of x, we would input an integer or a float here as x, and it would give us the absolute value. We can convert between integer and float. We'll talk a little bit more about that in the next section. We can do power operations, so x to the power of y. And then if we use a module, which we'll get more into later in the course as well, a math module, we can do various other things that are powerful with numbers. So let's show a few examples here. We've already done addition, my integer plus my float. We realized that creates a float. We can just use simple numbers now. Let's say 5 divided by 2, that's 2.5. Right, so that's just divided by 5 minus 2. Let's see, 5 times 3 is 15. We're just showing some simple mathematical operations. And let's talk about, let's do some power as well, some exponents here. 5 times 3, let's do 2 to make it simple. So 5 squared, 5 to the power of 2. is 25. 10 cubed, or 10 times 10 times 10, 10 to the power of 3, is 1,000. So we see that's how we can do some exponential calculations there. And I want to conclude this section with also showing modulus. So 5 mod 2. That's the same as 5 divided by 2 here, except it keeps whole numbers and gives us the remainder. So 5 divided by 2, if it were a whole number, well, it'd be 2 goes into 5 2 times with a remainder of 1. So 5 divided by 2, 5 divided by 2, but modulus means give us the remainder. And these are whole numbers. So the remainder is 1. So what if we do 6 mod 2? In other words, 6 divided by 2 would give us the remainder. The remainder is 0. What about 1 mod 2? Also 1. 2 mod 2. 0. 3 mod 2. 1. 4 mod 2. 0. I imagine you're seeing a pattern here. When we have an odd number and we do mod 2, the result is 1. When we have an even number and we do mod 2, the result is 0. So giving you a little preview of what's to come in future segments, future sections, we can easily determine if a number is even or odd using this modulus operator. So to conclude, we've done some simple mathematical operations, and there's many more as we saw in this list. Remember, we can also assign variables to replace our numbers or to represent our numbers. So my number 1 is, let's say 10. My num2 is 5.5. And then we can use my num1 times my num2. And that's the same as if we were just performing those operations on these values themselves, but we're using variables. Okay, on to the next section. The last bit that I want to highlight about numbers with Python is around type conversion. In other words, changing a variable between an integer and a float, as well as scientific notation and underscores in numbers. So scientific notation, we can type 1.5 E2. That's 1.5 times 10 to the second, which equals 150. If you're familiar with that type of writing, we can do that in Python. We can write the number this way and Python will understand it. We can also write the number, imagine these underscores are commas, in English at least, that we can write that to make it more readable. So 1 million, we can separate the 3 digits like that. And we'll get to those examples, but let's start with converting types between integers and float. So we can use these two methods, int and float, where the value inside the parentheses is our variable or our number. So let's try it out here. Let's say my int is 5. My float is 5.0. Okay. Now let's make a new variable, my new int, and let's change our float value into an integer. My new int is float, int of my float. Now let's break this down. We're running this int method in Python. It's just built into Python and it knows what to do when we use this. We're putting in my float, which is 5.0. There's a decimal there, so it's a float, and we're casting it, is what this is called, into an integer. My new int. Now let's see the type of my new int. it's an int now. So we converted this float into an integer. And we can do the same going the other way from an integer to a float. And we'll let you do that as an exercise on your own, but we would just do this with the float operation. And we'd have my integer, my int in here in the parentheses, and my new float could be a name for our variable. So for scientific notation, now moving on to that, we can type 1.5 e2. That's 1.5 times 10 to the second. So we know that Python understands scientific notation like that. And we can also type 1 underscore 000 underscore 000 for 1 million. So Python also understands that. Now we cannot do 1, 000, 000. So we cannot represent numbers like this in Python because it does not understand that to be an integer or a float. If I hit enter here, this actually signifies with these parentheses around here that is a tuple, that is, which is a different data type altogether. So if we say my tuple is 1, how we write these values in English is with a comma separating the every third digit. I know some places use a period there, but it's the same idea, right? To separate every 3 digits for readability. So let's see what happens if we view the type of this variable. Oh, there we go. It views it as a tuple, not an integer, not a float. So we just need to make sure that if we want to represent numbers in a readable format like this, we can use underscores, which is kind of neat. We just cannot use commas. And that is what I wanted to share with you in this section. Let's move on to the next. All right, let's continue on with this section talking about another data type, which is strings. So just a reminder that we like this vehicle analogy when we're talking about data types. And a string is one of those data types that Python understands, and it applies certain sets of rules to and knows that strings can do certain things. So as an overview, strings represent text, and they are a sequence of characters. In other words, we might say that strings are words in some senses and are made up of letters, if that makes more sense. But we'll talk about it in terms of characters a lot. And anytime we see a variable with the value being quoted, that is a string. Again, that is how Python knows that it is a string data type, going back to our vehicle analogy. And we can represent strings in multiple ways with either double quotes, single quotes, or triple quotes. If we use double quotes, then we can have within that double quoted area, we can have single quotes, and it won't disrupt Python. It will be fine with that. It will be able to print out that string and use that string just fine. If we have triple quotes surrounding a string, we can use double quotes or single quotes within that string, and Python will have no complaints about that. However, if we were to try to use a double quote and have another double quote, let's say just right here, we have a double quote, Python will think that's the end of the string, and then it will see this other text here and not know what to do with it. So just some tips about using strings and the type of quotation. Again, it makes no difference to Python which quotes we use, whether it's double or single. It's just best to stick to a convention that you like. And a reminder that triple quoted strings can span multiple lines. And one last thing is strings are immutable in the sense, and we'll get more into this, but in the sense that we cannot change the value of this string for a particular character. We cannot say this character of this string, we want it to be the letter Q, for example. We can assign a completely different value to that string, but we cannot change the existing string, and we'll get a little more into that later. Just something to note there. Let's now talk about concatenation with strings. And that's just a fancy way of saying combining strings or adding them together. And we can add strings together by using the plus operator. So we could make a new string variable and say that equals the value of string 1 plus the value of string 2. Let's take a look at an example of that. So if we come over here to idle and we say string 1 is assigned the value of hello, and string 2 is assigned the value of there, say string 3 is string 1 plus string 1 plus string 2. And now what happens if we print string 3 to the screen here? Get hello there. So we've added those characters just as they are within the string, no space characters. So it's all combined. And that is what I mean. That is what we mean when we say concatenation or adding these strings together. Now, what if we're trying to add an integer and we want to combine that with a string? Well, if we want to say my integer is assigned 5, what if we try to combine string 1 plus my integer? It's going to throw an error. You can only concatenate string to string, not integers. That's just a Python rule. So we can convert the integer to a string and then combine it with strings. So we could say, let's say string 4 is assigned a value of string 1 plus, and here's where the Python knows what to do with this. We say string str. We see how that's a different character, a different color, sorry. And we can say my integer. Within those parentheses, this is running a function, running a method that's built into Python, this str method, which converts my integer to a string. So now we can combine these two strings together without an error. And then if we print string 4, we see we've combined string 1 and my integer, just like that. So that's a handy way to combine strings, to combine a string with an integer. Let's talk about indexing and slicing strings. Indexing is a way to reference a character within a string, and slicing is to grab a chunk of the string, one character or more characters, based on a start and end value and even perhaps a step value. For example, we could grab every other character or every third character, etc. So let's first talk about indexing. And we see in this graphic here that each character in a string can be referenced with a numeric value. If we go from the beginning of the string, the first letter here, that is called positive indexing. So from left to right. If we go from the rightmost part of the string towards the left, that is called negative indexing. And we can use either one of those methods to reference characters within the string. 0 is the first character in a string. So if we reference the 0th position of any string, it will be the first character. It will represent the first character. And if we reference the last character, that's always with -1. And we just count forward if we're positive indexing and backwards if we're negative indexing. So let's take a look at that here in idle. If we say my string is hello world, and how we use this indexing is by referencing the variable or the string directly, and then open bracket, just a square bracket, and then the index position. So let's go back here. Let's say we want to reference this O from the leftmost part of the string. That's 0, 1, 2, 3, 4. O can be referenced with 4, with the number 4, or the fourth position. But remember, we're starting from the 0, and that's how most programming languages work, is to start with 0 in these index-based variables. So if we say my string 4, that is the letter O. My string 0 is indeed the first character in the string. Now, what will my string -1 be? If you recall, with that is negative indexing by having a negative sign there, and that starts from the rightmost side of the string. So that will be D, the last character. Let's do a few more examples here. -5. That's W. So -1, 2, 3, 4, 5. My string, what if we want to reference the space? We'd go 0 for the first character, 1, 2, 3, 4, 5. With positive indexing, this will be the space character. That is the space character. Nothing, right? It's a space character. So that's a little bit about indexing, and this is just something you'll just have to get used to. And it's just the way that we reference strings. It also comes into play later on in Python in other data types, such as lists, and we'll get a little bit more into that later. But just get familiar with this. 0 is the first character, -1 is the last, and that's how it works. So now, if we want to slice a string, in other words, grab chunks of the string, we can do that as well. And that is with this method of referencing the string, and then open square bracket, start position, colon, end position, close square bracket. So let's say we want to grab hello. It would be my string, opening bracket, 0 for the start position, and then end is actually non-inclusive. So we want to go one step farther than we need to grab. So we'll go 5, and I'll explain that here in a minute. But let's show you. So my string 0, 5, start and end, grabs hello. So how I like to think of this is the first character you want to grab, and then just go one beyond the last character you want to grab, and that's how far it will go. Or you could think of it, how many characters you want to grab. That might be a better way. So if we want to grab 1, 2, 3, 4, 5 characters, then we'd put that. So that may be a better way of thinking it. We can also add a step if we add colon and then step to this, and that will grab every other letter, for example, or every third letter. So we could do my string 0, 5. Remember, that will grab hello, and colon 1 will just grab every letter, every position. But if we do my string 0, 5, 2, the step is 2. So it grabs every other letter, HLO. So that is a little bit about strings and indexing and slicing. And one thing to be aware of and to watch out for is out of range indexing. So what if we try to reference the farther than our string actually is? So this 12th index with positive indexing. What if we try to reference a position that doesn't exist? Well, it will throw an error, as we see here with that example. But let's do it just to show you. My string 12. See, it's an index out of range. There is no index position 12 in my string. So that's an error to watch out for. And that's, again, a little bit about indexing and slicing strings. On to now one of my favorite things about Python 3 since version 3.6, which is f-strings. And simply put, it's a way to input variables into a larger string. And all we need to do here is prefix the string with the character f lowercase or f uppercase. And just before the opening quotation mark or before the triple quote. And if you recall, we did this for our story exercise at the very beginning of the course. We used an f string with triple quotes, so it could be a multi-line string to tell our story and insert our variables into our story. So here we have an example. We define a name as a string surrounded by quotes, right? And we define a variable age, which is equal to the value of 20. So that will be an integer because it's a whole number. And then we print f. Remember, we just insert this f character before the quotes. And this is surrounded by quotes, as we see here. And then within the string, we just include any variable we want inside of curly braces. So this will replace name, the variable name, with Alice, and the variable age with 20. And as we see, it prints this out here. Alice is 20 years old. So it's a very simple way to use these variables in a string. Now let's show an example. So let's say color. Let's say car color is blue. Let's say car model or make is Honda. And let's say my name is, let's say, well, I'll just put my name for ease. Now let's print f. Remember, always put the f there if we want to do an f string and use this syntax for printing variables. So my name owns and then car color car make. And we're going to replace my name with Joseph, car color with blue, and car make with Honda. And that's what an f string does. So let's hit enter here. Joseph owns a blue Honda. So it's a very simple way of adding these variables into our string for printing or other uses. And just really love that feature of Python. It's made it very intuitive to do this. So that's a little bit about f strings. Strings have some very powerful methods and operations that we can take advantage of. So we're going to talk about that. Methods of strings are mechanisms that allow us to rely on some built-in code, built-in functionality with Python for a lot of common or useful tasks. So let's look here at our docs, our Python docs, and over at docs.python.org, we can see string methods. There are a lot of them: string.capitalize, casefold, count, etc. And we could have a string, let's say my string, equals hello. And so we would put my string, and then how we use this method is dot after the string, and then we call the method capitalize. These parentheses are what call the method. In front of the parentheses are the method name, of course. So also, if we look at common sequence operations, this we will talk about as well. Strings support these common sequence operations, and we're going to get into this, but just some more powerful ways to use and manipulate strings. So I wanted you to be aware of that documentation that you can peruse whenever you would like. So here I've got some samples of common string methods, and we see over here executing some of that. If we say my string is equal to this is a sentence, remember our strings are surrounded by quotes, double or single. And then we say my string dot capitalize. And these parentheses here, that calls the capitalize method on my string. And we see that returns this is a sentence with a capital T at the beginning. My string dot upper returns all capitalized letters. My string dot replace, we can replace S with P. That returns a very interesting string, doesn't it? My string dot title capitalizes the first letter of every word. So you can see how that could be useful. We can also check to see if my string starts with the letter T, which it does, as we see here. Or if my string ends with, let's say, the letter W. It does not end with the letter W. And we'll get more into these true and false values, Booleans, in a few lectures. One thing to remember is that strings are immutable, meaning these methods that actually return values or that give values back to us after we call a method on a string, they return new strings. They don't change my string. So let me show you that. Let's say my string equals hello. What if we do my string dot upper? We see that returns all uppercase hello. What is the value of my string? Is it this uppercase hello or this lowercase? Well, what we just learned is these methods that return values return new strings. So my string is unmodified, and it's this lowercase hello. Let's prove that. If we print my string, we see it's still the lowercase hello. Strings are immutable. They don't change. We have to explicitly change the variable. So let's say my string, if we want to change the value of my string to be all uppercase, we'd have to say my string equals my string dot upper. So we're assigning now my string a new value of my string dot upper. Now if we print my string, we can see hello is the value of my string. So that's how we can kind of get around that immutable aspect of strings. So those are some common methods I wanted you to be aware of when working with strings. Moving on now to string operations. And these are some other powerful things we can do with strings that are built into Python. We saw this table at the Python documentation site, and we can use all of these things on strings. So some examples over here on the right. My string, we're setting it to a value of hello. If we do a min, which we see over here, min of string, it's the smallest item of S, smallest item of the string, which is alphabetical. So the lowest alphabetical character in my string is E in this case, as we've called min on my string. E is the lowest, if you will, value in the alphabet of that string. The max value in that string hello is O. The length of my string is 5 characters. 1, 2, 3, 4, 5. Let me see over here. That's what the length does. We can count the number of occurrences of a character. My string.count. That returns 2 letter L's. We can multiply our string by itself. My string times 2 is hello, hello. So it creates a new string there. And we can also see if a character is in my string. Is the letter H in my string? That is true. Again, we'll get more into Booleans, this true or false value later on in the course. So don't worry about that too much right now. But I just wanted to show you there's a lot of these operations. I wanted to make sure you're aware that they exist, so you're not trying to write these functions yourself, these methods and operations on strings. They can be extremely useful, and you need to be aware of many of them. The more you learn about them, the better. Another thing that is essential to know about in Python and most programming languages is this concept called escape sequences or escape characters. And what these are a way that Python understands how to interpret certain characters that do certain things, or characters or sequences that have special meaning. And that's what is meant by this section here. So if we have some text and it spans multiple lines, at the end of each line, there will be a new line character, which is represented by a backslash and then an N. A backslash followed by one or more characters is how we represent these escape sequences. So we're going to come back to this, but let's go take a look in idle, and I'll show you what I mean when I'm talking about these escape sequences. So let's say I want to print, hi, let's say Joseph says, hi, Bob. Wow, what do you see what just happened there? I'm trying to say a sentence. I'm trying to create a sentence and put quotes around this hi Bob part. But Python thinks, because this is my start quote, that this is the end quote of my string. So what's going to happen here? We're going to run into an error. So how would we print this if we wanted to just say Joseph says and then just have quotes around hi Bob? Well, that's where we use escape characters. So we could do print Joseph says backslash. Remember, that's always the start of these escape sequences, and then a quotation. So Python will interpret that. It understands that's an escape character, escape sequence. Hi, Bob. Then we can do it again. And now it will interpret those literally. It will print those out instead of interpreting that as the end of our string. And then we can add one more quotation mark to complete the string. Now we can see that worked. So keep in mind, this is just how Python works. We need these escape characters to help Python understand what we're trying to do. So let's look at some other ones, this new line and tab. And what I just showed you with the double quote, it's the same thing with what can be used with a single quote, by the way. We'll come back to that. But let's print Joseph. Watch what I do here. Backslash n, Bob, backslash n, Robert, backslash n. That's a special character sequence. That's a new line escape sequence. So that's what Python interprets it as. Joseph, Bob, Robert, all on new lines, as if these characters are here, they're just not visible. They're at the end of these words, they're just not visible. We could do the same thing with the tab escape character. Backslash, remember that starts our escape character. Backslash T, Joseph, Let's do that again. \t, Bob, \t, Robert. Now we've got tabs in between all of these. And it looks a little funny with idle here, but you'll have to trust me that those are tab characters. So let's come back to that single quote. We talked about this a little bit at the beginning of the course with strings. You can use double quotes or single quotes to represent strings. If we use double quotes, we can have as many single quotes within it as we want, and then end with a double quote, and it prints those. But if we use single quotes to encapsulate the string, there, let's do some English here. There, let's say I want to say they are. Well, you see, I'm trying to type that, but Python interprets that as the end of my string. If I just want to say there, then I have to escape that special character. So / and then the special character. That's our escape sequence. And then it will print there. Also with a /, sometimes Python will interpret this in a way that we don't intend. So if we literally want to print a /, we can do the same thing. Let's say / and then another / will print one /. So I wanted to make sure you're aware of those, and they can be useful in various scenarios. And we'll come back to this more throughout the course, but you need to be aware of it. You need to understand what that's doing. It's just one of the ways that Python works. So these escape sequences are important to know about. One last thing about strings that also applies to other data types, other objects as well, is dir and help. These dir and help methods. These can show us more useful data about the objects we're trying to work with. Dir shows us the available attributes and methods of a data type. So we could put a string within the parentheses of dir, and it will show the available methods on that string. I will show you this in action, but want you to be aware that special dunder methods, as they're called, with these lines, these underscores surrounding the method name, are properties or values associated with the string object. And then just methods, which are just shown as the name of a method, the text of it, are functions that can be called on the object to perform various operations or manipulations. And we did talk about several of these a few lecture videos back. And then the help method can show helpful information about a data type or attribute or method. So we can call help and then put the string in there, or we can put our string in here, dot title or dot capitalize. We could put our string literal right this, or a variable in there. So let's show you a few examples of dir and help and how these show some useful things about these objects. So if we say new string equals, let's say, earth. Now what if we do dir on new string? We see all this gibberish that pops up. Now, if you remember in the last slide, we talked about dunder methods, which are surrounded by these underscores, and then the name of the method, and then regular methods, which are just the name. And so these dunder methods are properties or values. So we see some of these here. One you'll recognize is length. For length, we can call length on a string. So we could say length of new string. And the string object knows, it has a special way of interpreting that and understanding that, and it knows to return the number of characters in the string. And then if we look at all these other methods here that don't have that dunder around them, those underscores, we can see that these are our methods that we can call from the string. So new string dot, and then any one of these methods. So let's pick a random one of, well, maybe not a random one. Let's see, count, right? And then we could put the occurrence of a letter in there. I don't know, X, but we know that's not in there. So there's zero letters X in our string. We can also do, so that's the dir. That's the dir method, very helpful. We can also do help on, let's try this on new string. So we see there's no documentation for our string. But if we do help on string, str, which is the actual data type, we see there's lots of output and there we go. It didn't want to return it all, but there it's returning it. And we see documentation about the string object. Let's go to the top here. It's help on the class string in the built-in modules. Tells you what it does, defines all the methods. It's another way, we see these dunder methods and then the regular methods. It's another way of showing more information about than dir. Now we can also do a concise way of doing this. So help, a new string, and then we could do dot and one of these methods. So let's try that. We'll scroll all the way to the bottom here. If we can. There we go. Help, new string, dot, capitalize. That's one of the methods for strings. So we can see it outputs the help text of the capitalized method for a string. So wanted to show you that, dir and help, and these can be quick ways to find out more information about our strings or other data types. All right, everybody, this is a monumental moment in our Python journey. We are moving on to learning how to execute Python code with text editors. And this will help us to write larger programs, and we can essentially do anything we need to with a text editor, running scripts from text files as opposed to idle or the shell, the Python shell, like we have been doing up to this point in the course. So we can write some Python code, we can save the file, we can edit it later, and we can run it. So how we run Python scripts with text files is just a few simple steps, and we will demonstrate these. We want to save a Python file, first of all, with the extension .py. So myscript.py, for example. And that lets our systems know that it's a Python file. And it also lets us know that it's a Python file. We then want to open a terminal or command prompt, depending on if we are on Mac or Windows. I will show some examples of both. Then let's navigate to the directory where our Python script is located within terminal or command prompt so that we can execute the script from the location where it is. And then on the terminal or command prompt, we will type simply Python followed by the name of our script file, which will have that .py extension. And then we'll hit enter, and that will run the script. One note is if we have both Python 2 and Python 3 installed on our system, or we have various different Python versions and we want to run a script with a certain version, we can specify by modifying this to be Python 2 or Python 3 or Python 3.11, etc. We can modify that, and that will invoke that specific Python interpreter. All right, we are now on a Windows computer, And as you can see here, I've got Notepad++ opened up, another text editing program. Over here on the right, I've got command prompt on the bottom left. And I just opened that by going to the Windows icon and typing command prompt and clicking on that. And then I've got my file browser up here in the top left in this My Scripts location. So let's create a new file and show you how to do this in Windows, very similar to Mac. And let's just make it a little bit more interesting. Let's say my name is Joseph. Favorite color equals blue. And we learned about f strings, so let's do an f string. F. My name is my name. And let's do another one. I'm spanning these across multiple lines because I have my text quite large to make it easier for you to see. My favorite color is favorite color. Let's just autocomplete that. We got to scroll a little bit here. Okay. Now let's save it. File, save as. We've got this my scripts location, new script. Remember .py for that extension. .py, save. Okay, and then because we have that .py extension, our text editor, like many, recognizes it's Python code and it colorizes it appropriately. So we see that new script popped up here. Now in command prompt, I need to navigate to desktop and my scripts, the my scripts folder. Remember, we need to execute our scripts from the same directory where they are located. Let's do cd. That's the same on a Mac, same on a Linux. Cd, change directory, and then the location of our directory from where we are currently located or the absolute path. If you have questions on that or want a refresher on navigating in command prompt or terminal, a quick Google search will yield all the results you need. I promise you that. So just a few basic commands that we need to know to run Python scripts. That's it. So let's cd desktop, my scripts. Okay. In Windows, we can type the dir command to see what is in our location. And we see new script is indeed in our same location where our command prompt is at right now. So then we can type Python new script.py. That's the name of our script. Hit enter. There we go. My name is Joseph. My favorite color is blue. So I hope that helps you guys get up and running with writing code in text editors with Python and saving files. You can work on them later, and we can execute the Python scripts from command prompt or a terminal. All right, we'll see you in the next lecture. So let's take a look at how this works. Over here, I've got three things open on my Mac computer. And again, we will show also on Windows here in a minute. I have a text editor. This is Sublime Text. There's lots of different editors, and we'll talk a little bit about those in the next lecture. And it's just, we simply can write text. We can write code. We can write whatever we want here. I've also got my terminal going, and I've got a file browser just for two ways of seeing where our files are located. So let's write some Python code. Let's just write print hello there. Okay, so I've written text, I've written Python code in my text editor. Let's save that. And I'm going to name it myscript.py. I know the location of this script. We'll save it. And that's where the script now shows up in our file system. I am also there in terminal, pwd is a Mac command, print working directory, that shows the location where I'm at in terminal. And this is my location. I'm in this test scripts folder. ls shows us, again, on a Mac or Linux system, the contents of that directory, which are two files, myscript.py and untitled. We don't need to worry about untitled. And so myscript.py. So we see we are in the correct location. So remember, now to run it, we can just type Python myscript.py. And we see that it printed out hello there in our terminal. I can close this text editor. I can work on it later. I can come back to it. And we have a persistent way now of running Python scripts and writing Python code. I have a few different Python versions on my system, so I could also try Python and just tab. We see I have various versions. I could say Python 3.11. That will invoke the Python 3.11 interpreter, myscript.py, and that works as well. I wanted to end this section with just a few quick notes on some popular text editors. There are others, of course. This is just a small list that I've compiled. And note that text editors are really just a preference. So use what you like, use what your team likes that you're working with, if you so desire. Make collaboration a bit easier. But we've already used idle in Python. I just showed you Sublime Text. Notepad++ is another one I've used. I know a lot of developers who love Atom. And Vim, that's a very lightweight text editor that we will talk about at the end of this course. I'll give you a tutorial on that. It's very powerful for being so lightweight, and it is installed by default on most Linux systems. So when we're editing code and scripts on Linux remote systems, for example, or local systems, that can be very helpful. And VS Code, I put an asterisk there because that is definitely a text editor, dare I say, that is gaining a lot of popularity and I think is very worthwhile to learn. It is also a full-fledged IDE, Integrated Development Environment, which we will get into more later in the course. But if you were to learn one text editor, if you do not have any text editors that you know, I'd suggest something simple like Notepad++ or Sublime Text. And if you've already used some text editors and are looking to grow your capacities a little bit, I would suggest VS Code because that's also the IDE we'll be using later in this course. Any one of these can be downloaded from the internet and we can run Python scripts just as we've demonstrated in the previous lecture video. I wanted to just show you real quick idle as well and how that can be a text editor for us. So if we go back over here and we open our idle program, this is just some leftover code that I have, but we can go File, New File, and this it can work as our text editor in idle directly. And we can save this. myscripts.py, and we'll save it in this location again. Let's say myscript2.py, print, cool. Okay, and then we'll save it again. And we can actually run this straight from idle as well, run module. And we see that it actually ran our file within idle, printed out cool. So that's another simple way to run Python scripts if all you have is the default installation of Python, including idle. Now that we've talked about some fundamental data types of Python, we are going to do a fun little project, a Mad Lib project, and talk about making our programs a bit more interactive with the input method. So up to this point, we haven't actually taken any user input at the terminal. But what the input method does is that allows us to take input at the terminal, and we can make our programs interactive. So I think this will be a fun project, and it's very useful when we're writing programs. So input gets input from the user at the command line prompt. It reads a line from the input that the user types in and converts it to a string and returns that string. That's very important. If we want to return a number, we have to convert it to a number with typecasting, which is something that we've discussed. This input method takes an optional string argument, which is displayed as the prompt to the user. So we have an age variable here. We're assigning to the value that's returned from this input function. The argument here is enter your age. It's a string. So this is what the user will see. They'll see enter your age, colon, space, and then their input will follow. Age will be assigned the value of that input as a string. We're then going to typecast age into an integer. Now we see that's 2 lines of code. We could also do it this way with 1 line of code, which I'd suggest. If we know we need an integer, we can just do int and call that int method, make sure we're surrounding in parentheses, and then within that, our input method. So what's returned from input will get passed into the int method, which will then get assigned to age. And then we could print out you are in our age variable, years old, using an f string. Let's walk through a few examples of the input method, and then we'll get into our Lib project, and I'll describe that. So first of all, I've got my myscript.py file, and we're going to add some Python to it. Let's assign a name, variable name to input, calling the input method, and then as an argument to that method. And what that means by argument is what's inside our parentheses that the input method can use as it processes. We're going to say, what is your name? We'll hit a space just so the prompt, the user isn't typing immediately following that question mark. There's a space and then their text will follow. Let's say number 1 is input, enter number 1, and number 2, input, enter number 2. Okay, and then what I'm going to do is I'll have the values of these 3 variables once the user actually inputs them, and we'll just say, we'll print them out. So let's print with an f string. I love my f strings. Love our f strings. F string name says that num1 plus num2 equals, and then we'll just do the result here of num1 plus num2. So we can do this operation here within our curly braces, which is so nice with f strings. So let's save this. I'm saving that with Command S or Control S on a Windows, and then let's run it. Python my script. What is your name? Joseph. Enter number 1. 5. Enter number 2. 3. Joseph says. Okay, this is a great example, guys, of why we need to be careful with our integers and strings, because what happened here? Joseph says that 5 plus 3 equals 53. So what happened here? I want you to think about that. What is the type of num1 and num2? Let's see. Type, let's do num1. Let's run that again. Joseph, let's just do 5 and 5. It's a string. So I didn't want to edit this out because I think it's a great demonstration to show you what happens when you don't convert these to integers or to numbers, either an integer or a float. I'm just going to convert them to integers, and it just concatenated these two strings. So it's concatenating the string 5 and the string 3. So with input, we need to typecast to an integer or a float if we want to do our mathematical operations here. I'm just going to do integers to make it simple. Now let's try again. Let's clear our screen. Joseph, let's say 10 and 7. So now we've got it right. Joseph says that 10 plus 7 equals 17. So that's just a cool little demonstration of our using our input method. So now let's get into our project. And what I've got here is some code. I'm going to paste that into my script.py. And this is just a little story that takes a lot of inputs. Now, if you've never played the game Mad Lib, it's a game where you select a bunch of words and you don't know the story that these words will be injected into. So you're just selecting random words, and it becomes quite funny because once you read the story with the words, you copy the words over to the story and you read the story, it can be quite funny because the words often have nothing to do with the story. So that's what Mad Lib is. So for our project, we're creating a Mad Lib, and we're using our input method, to store all of our words. And then we're using an F string, a multi-line F string, to then print out our story. We're inserting all of our variables into that story. Then we're printing out the story. So this text, if you would like a baseline, is in the next lecture. You can just copy that if you'd like and modify it as you see fit, or you can create your own story. And so that's the project. It's to create a Mad Lib. We're taking inputs and we're printing them out, and we're creating a Mad Lib. This is something you can show your friends, and it's a fun little project that can be a fun exercise for you. So I'm going to run this. I've saved the file, and I'm going to run this. So I'm just going to enter all my variables. I'll probably fast forward through this part. All right, I've entered in all of my inputs here, and I do apologize if English is not a natural language for you. These are just constructs in English. You can change them how you see fit, but just how grammatically English works with verbs and nouns and etc. I assume you have a very good understanding of English if you're watching this video lecture series. But what's happened is we've entered all those inputs up above, and then our story is printed out for us down here. So what it turns out to be is, once upon a time in a land far away, there was a curly programmer named Joseph. Every day, Joseph would wake up and run with great enthusiasm. One day, while jumping, Joseph stumbled upon a magical building that changed everything. This building was tall and full of cats. Joseph decided to quickly stomp the building and found a secret message that said, "Always keep your dog clean and your code cleaner." So, a fun little exercise, guys. I hope you have fun with that and get familiar with the input method, and can maybe show that off to your family or friends. We will see you in the next lecture. Welcome to our lecture on Booleans. They are another data type They are binary, meaning they can only have one of two values, true or false. And they're essentially the result of yes, no questions. Is the sky blue? Is the Earth a planet? Is the stoplight color red? Yes, no questions. We can ask questions that are yes, no, or true, false, and we can use these Boolean data types in Python to help us with that. We can assign these to variables directly with direct assignment. A is assigned to the value of true, or B is assigned to the value of false, for example, or with the result of comparisons. 5 greater than 3 results in true, because that is a true statement. Note the capitalized first letter in our Booleans. Capital T, capital F. That is necessary. Some programming languages don't require that, but Python understands true or false only when you have a capital T or a capital F. That's how it understands those Booleans. We're going to come back to a bool function, which can help us evaluate objects in a Boolean way. For example, bool of false returns a result of false. So we're evaluating whatever's in the parentheses here, and bool will tell us if that's true or false. We'll come back to that. I've also included a truth table here just for some understanding, and you can refer to this of how true and false is interpreted. If we have two variables, variable A and variable B, and we can do and, or not on these values, we have different results. So we'll come back to that here in a bit. Booleans have various logical operations that we can use to help us compare. We have operators and, or, and not, and comparison operators equal to, not equal to. Just you can see here how these are defined in Python. Greater than, less than, greater than or equal to, and less than or equal to. And we can combine these and use parentheses for order of operations, and we'll show an example of that. So let's look here on the right, and we have assigned the variable x to a value of false. The variable y is a value of true. These are Boolean data types. What if we say x or y? So we're trying to evaluate that expression. Well, that evaluates to true because x or y is true. Y is true. What if we ask, is x and y? And that is false because they would both need to be true to evaluate as true, but only one is. Only y is true. X is false. Now here's an interesting example. What if we say not x or y? Well, let's evaluate left to right. Not x evaluates to the opposite of x. Not, as we see here, reverses the Boolean. So not x would be true. Not x would be true. Well, now what about or y? So true or, what is y? True. So true or true is true. And that's the result of that. Look here, if all we change is we add parentheses for order of operations, and we say, evaluate this first, x or y, and then we not it. So x or y, well, we already know that is true from this operation because one of these is true, y is true. So we have true, and then if we say not true, that evaluates to false. So I wanted you to be aware of that order of operations. We can use that similarly as we use in regular math. We can use that in Python. Let's look at a few more examples with comparison operators over in idle. So here we have x is assigned the value of 1, y is assigned the value of 2. Let's have a third variable z, and let's assign that the value of 1. So is x greater than y? No. Is x greater than z? No. Is x greater than or equal to z? Yes, it is, because it's equal to z. Is y equal to z? No. One thing to be careful of is double equal sign versus a single equal sign. Let's see what happens if we do y equals z. We might think, oh, is y equal to z? All that does is that makes y take on the same value as z. So now y should be 1. Let's check that. Y is indeed 1. So remember, double equal sign is for comparison, and single equal sign is for assignment. So that was a little bit of logical operations. I'd invite you to and encourage you to try some out on your own, and we will see you in the next lecture. Lastly, with Booleans, let's talk about a concept of truthy and falsy. In other words, not necessarily having a direct correlation to true or false, or yes or no. However, Python will interpret these as true or false. So, some common values that are falsy are 0 or empty data types. Some common truthy values are non-zero numbers and data types that contain one or more value. And this comes into play in Python a lot. We'll see later on, for example, with loops and with if statements. Booleans are a big part of those because they rely on evaluations of true or false. So these falsy and truthy values really come into play there. Let's take a look at some examples. Starting over here on the left, if we assign x to the value of 5, and we use this nifty bool method to evaluate x, that is true. That is because it is a non-zero number. 5 is a non-zero number. So Python sees that as true if it needs to evaluate it in a Boolean case, which, as I said, there are some instances where that does come into play, and we'll see those later. Y is assigned 0. Now let's evaluate that as a Boolean. Y, that is false because y is 0, and that is a falsy value. Z is assigned -1. That is true. The Boolean result of that is true because it is not 0. So even negative numbers result in true. Data types that contain one or more values. So here we have a list. We'll talk about these later in the course. This is an empty list, and I'm not showing that here in the screenshot. I apologize for that, but it's an empty list, and it evaluates to false. And you can envision that in your head as if these numbers are missing, and my list is just assigned to open bracket, close bracket. Now, if we actually have some values in my list, 1, 2, and 3, and then evaluate that as a Boolean, that results in true. Same thing with a string. If we have an empty string, the Boolean result of that is false. If it contains anything, then the Boolean result of that is true. So I wanted you to be aware of truthy and falsy values and prep you for what is to come in the course, and it's a very essential concept in Python. This marks an exciting milestone in our Python journey. We are now learning about lists, which are another Python data type, a very powerful one. So when you're able to master lists, which you will be able to after these few lectures, you can leverage this powerful Python data type. So lists are an ordered mutable collection of items. If you recall, mutable means the values can change, whereas immutable means they cannot. And that's different from a string in that a string is immutable. So we cannot actually change the characters in a string. We cannot modify them, but we can modify the items in a list. And we'll show examples of this. We can also, going off of how these are similar, how they compare and contrast with strings, they are similar to strings in that we can also use an ordered index and slicing like strings. Lists can also contain multiple object types, like a string and an integer at the same time. We see down here an example of a list defined by creating our variable, equal sign, open square bracket, close square bracket at the end, and in between the square brackets, we can have our data types or our data separated by commas. So we have one item in the list, another one, 3, 4, 5, 6. They have zero-based indexing like strings. So remember, if I were to say an easy way to remember lists and how to use them, they're very similar to strings in a lot of ways. So my list 0 would be car. So the first element in a list, just like the first character in a string, is 0. Use zero-based indexing. I think of lists as a train, and each car can carry different cargo. Each car of the train can carry different cargo, and it can be a very long train. So that helps us visualize what a list can do and how powerful it can be. Before I show you an example of modifying a list, we will also look at the Python documentation. I wanted to show you something over here. This is on docs.python.org. I just want to reiterate that there's so many great resources on the official Python documentation. And here's one that talks a little bit about lists. We see some list methods, which we'll talk about as well, and plenty of examples. I have found it's very thorough, as it should be, the Python documentation. So it's not necessarily all beginner level material. I myself find some of it is a bit complex or a higher level, a higher advanced level. So just bear that in mind. But how you can find this tutorial is by going to the python.org website, looking at documentation, and then here we see some resources. And here's this tutorial. So if we click on that, we see all sorts of interesting information about Python. And just wanted to refer you back to that and invite you to visit that as you can and know that it's a great resource to help you. Now, last thing on this introduction to lists is just a brief primer on modifying list items. So we saw here on this first line, we can define a list like this. Again, our variable equals open square bracket. Make sure you have the close square bracket as well to match. And then in between our values separated by commas. Separated by commas. And we can have different data types. So to modify a list, we can select my list. This is the simple way. And then just like strings, input the index, so square brackets, and then the index number inside, and change that value to what we want it to be. Now if we print the list, we see the first element, or the 0th index element, is now truck, which we've changed from car. So that's a brief introduction on lists, and looking forward to discussing this powerful Python data type more with you. Lists, indexing, and slicing. First thing I want to point out is that, as I mentioned earlier, it's very similar to strings as far as indexing and slicing go. And so we will talk about that in this lecture, as well as a few other nice to know things. First of all, how to create a list. We create a variable and assign it to square brackets. It can be empty. It can be just square brackets that will create an empty list. Or we can have our data within the square brackets. Needs the square brackets. Each entry in the list is separated by a comma. As we see here, comma, comma, comma. Very important. That's how Python knows what's in a list. Don't worry about this little bit right here. I will talk about this in a second. You see there are multiple commas here, but that is only one entry in the list. We can also use this construct of list and parentheses to create a list. Now, as far as indexing and slicing, if we recall what we've talked about with strings earlier in the course, are two ways to do this. We can do positive indexing or negative indexing. And it works the same way as strings. Positive indexing will go from the leftmost part of the list towards the right. And again, it's zero based. So the first item in our list, and this represents our list right here, the very first item in our list, car, we see the very leftmost item, is referenced with the 0th position. And as we go to the right, we increase the number. So in this case, the third item in the list is represented with the second index position because we start at 0. So tree would be referenced with the second index position. And negative indexing is just the inverse of that. The last item in the list is -1. That's the last item, whatever it is. So in this case, it would be true. And I do have a slight typo there. This should be only uppercase T, lowercase RUE, as we see here. I apologize for that. And as we reverse index just towards the left, we just increase the negative value or decrease the actual value, as we see that working there. And slicing, we can select portions of the list with a start and an end, or a start, end, and step. In other words, move forward this many positions. That's what the step is at a time. So we could select this item, every other item, for example, using a step. And one note is end is non-inclusive. So if we do start, end, that will not be the actual value. If we end at the 4th index, it will be this value will be the end. And I'll show you an example of that. One thing to watch out for is out of range indexing, just like strings. So if we have our list defined, this is the same list I've defined up here, and we have 1, 2, 3, 4, 5, 6 items in the list. So if we print the 5th item with our 5th index item, which if we look here is actually the 6th item, we see that it prints out true. But if we try to reference an index position that is not within our list, we will get an index error. So index position 6 we see does not exist. That would be one more. So watch out for out of range indexing. And lastly, before we dive into some examples, nesting. I want to mention nesting. And that is how we can have a list or multiple lists inside of a list. That is what this 4th index position item is. It's another list. So if we access this item at the 4th index position, it will return a separate list. And that is called nesting. Nesting a list inside of a list. All right, let's look at a few examples here. So we've got my list, and that is assigned this value. Remember, open square bracket, close square bracket, and then values separated by commas. So what if we want to access the 0th element, the 0th index position, but the first element? That will return car. What if we want to access the first 3 items? We can slice it 0 through, and now remember that last element is non-inclusive. We will go to 3. However, that index position would be this item, but it won't include that. It will include these 3 items. As we see, car, 5, tree. Negative indexing, we can do -1. That will give us the last element in the list, always, which is true, in this case, a Boolean, which we've learned about Booleans. And let's go back here and see if there's anything else we want to discuss. I think that is it for this slide and for this lecture. So we will see you in the next lecture with more about lists. On to now our last topic with respect to lists. Let's talk about iteration. Lists are what we call an iterable. Like strings, we can iterate through each element or item in the list one at a time and process that. And iterables need a good way to look at each element within them, within their contents. I'm going to preview for you for loops. We will talk more about for loops later in the course, but I'm going to preview for loops for you because it's important to understand how we can look at each element in a list. And there are 2 ways to do it. So I'm going to go over here and we'll show you. And I've got a text file, which I've created some Python code in. And up here in the top left, I've got my terminal and then just a file browser to show you that my script resides here. So in my terminal, if I print working directory, I'm on a Mac. On Windows, it would be dir, D-I-R, to show your current directory. I'm also going to do ls on a Mac to show that my script resides within this directory. So if we run Python, my script, it will run this code that I have here. So I've defined a list, the same list we've been working with, and I'm going to show you each one of these 2 examples of iterating through a list, which are very useful. We'll comment out the second example for now, and we will work on the first example. So I commented that. I'll save the file with Command S, Control S on a Windows. So we will just execute this code right here. All the rest of the code will not execute because it's commented out with our hashtags or pound signs. So let's run it. And we see that we output every single item in the list. Now let me walk you through this for loop. For every item, this can be whatever word you want it to be. It does not matter. For item in the list, in my list, that references my list. And then we have a colon, and we indent 4 spaces or a tab. We indent underneath our for loop. This is a good preview for loops. For every item in the list, print the item. And that accomplishes printing out each item in the list. We could call this, let's do it for the sake of showing you, we could call this bleh, like it really doesn't matter, bleh, as long as they match. We are just saying this is how I want to reference each element, is with this temporary or local variable. And then we can reference that variable here. Let's run that again. We're running the script, same exact output. So it doesn't matter what this variable is called. Item is a common way that you'll see it is with item. So I'm going to change that back to not add confusion. Now let's comment that out and show you a second way of iterating through a list. And we could do a lot more than just print here. We could do whatever we want with that. But print is an easy way to show you that it iterates through each item. So we could have more Python code indented here and do the and process that. So this second method I want to show you will also give the index position, which can be very useful. Sometimes we need to capture which index an element is at. So to do that, we can do another for loop. And remember, this for loop is commented out, so it's not going to be processed. We can say for index item, these two values, it doesn't matter what they are. We are just creating them temporarily, and then we will reference them locally here. So we could have this be called anything. But then we say in enumerate. This is a keyword. And then within these parentheses, insert our mylist, our list variable. Then a colon. This is just how Python understands how to use for loops. We always need that colon. Then our tab or 4 spaces down here, and then we'll print both the index and the item. So let's run that. We'll save it. Let me clear my terminal here and then up arrow to run that script with Python myscript.py. That did not work because I have an extra indent here. That's a good example of an indentation error. So I need to delete that. And now let's verify we have the proper spacing. One, that's a tab, which is 4 spaces in my editor. There we go. Let's save and try again. There we go. So we now have each index position over here in the left column, and then our values in the right column. And that you will find is very handy. So this enumerate tool in Python can be very useful because it captures both the index and the item. So wanted to show you an example of list iteration and put that in your back pocket, and I'm certain we'll come back to it later on in the course. Lists have some powerful methods associated with them, and I'm going to demonstrate several of those with you now. But first of all, I want to emphasize again, I've mentioned these earlier in the course, but repetition is a great principle of learning. Dir and help. These are helpful tools from the Python command line that can help us learning about our objects and learning about Python. So we're going to look at that, at dir and help, and we'll see some of these methods, and then we will jump into actually using them and showing some examples. So here we have our previous list, car, 5, tree, 11.6, 1, 2, 3, true. This is the list we'll be working with. Well, if we do dir on my list, we can see these are the available attributes. Remember with this dunder method is what those lines are, as well as our methods, which do not have those underscores. So starting here and going all the way over down to here are the available methods on a list. We can also do dir on the list data type. We see how this is a different color. This is a purple. That's a reserved keyword. And that will show us the same thing because my list is a list. So either way will work. We can also do help on my list, and we can actually select one of these methods. So we could do mylist.pop, and we see that shows us some help on the pop method. We see that the default value here is the last item in the list, index of -1. It will pop the last item that's by default, and it will remove and return the item at that index. So if we want to access that value or save it to another variable, pop will give us that last element in the list back, and we could assign that to another variable if we so desire. So just wanted to remind you about the dir and help functions. We could also do help on just my list. Actually, maybe not. Actually, yes. We see it just squeezed the text. There we go. So look at all this here. It's lots of documentation, and we can easily read about that. So very, very helpful. Okay, let's start over with our clear screen here. We've defined our list. Let's try some of these methods. We can do my list dot reverse. And we can see it reverses all of the elements from last to first. We can do, I want to go back to our slide here. We could do mylist.sort. And this sorts the list alphabetically or numerically. However, they need to be the same type. So we can't sort a list that contains both integers and strings, for example. But that can be useful for us. We can add elements to the list with append, and we can add, let's add false. This appends to the end of the list. So we've now added false to the end of the list. We can add elements at a given position in the lists with insert. And here we see we need to first indicate which index, and it will be inserted before the index, and then our object we want to insert. So let's insert something after 11.6. So that's the index position 0, 1, 2. So let's insert it before 11.6, so before 2. So our index will be 2, and then we can insert, let's say, 100. The value 100. Now we see we've inserted the value 100 before that position. Let's come over here and look at a few other useful methods. We can express the length. That's one of these attributes of the list. So print the length of my list. How many elements are in my list? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. And that can definitely be very useful. Let's end off with, let's do pop and count. mylist.pop. And this, if we look at the help for this, by default, as we've mentioned, it will pop the last element. So if we just do pop, and it returns it, as we see here. So it removed that and returned it for us. So we could say new var is assigned, and then do mylist.pop. And that would have stored the value false in there, in that new var. If we print our list now, we see it no longer contains false, which was that last element. We can also pop or remove items from a specific index if we change this parameter. So we could pop the first element in the list by specifying the 0th index position. So we'll pop true off of the list. Now let's print our list. And we see there's no longer true represented there. Our first element is this other nested list. Lastly, we can count occurrences of a specific value. MyList.count. Let's count how many occurrences of tree there are. There's one. For the sake of showing you more about this, let's append tree again. Lists can contain duplicates. Let's print that. So we see we have tree here and tree here. Let's count tree again. Now we see there are 2 instances of tree. So we'll end with that on this lecture. A lot of useful methods. We have not covered them all that we can use with lists that just make them that much more powerful for us. Welcome to the section on dictionaries, which is another very useful Python data type. Let's introduce dictionaries. They are an unordered, order doesn't matter, a collection of data in a key value pair form separated by commas, with one exception. Let's dissect this sentence bit by bit. And here we have an example of a dictionary defined in Python. So key value pair means that to get to a value, we reference the key, and that will give us this value. So the value can kind of have a name that it's used to reference it. And each entry is separated by a comma, except the very last entry. And this is the same with lists. So if we look at our dictionary down here, the name of our dictionary variable is person. We're assigning the person to this dictionary. And a dictionary is curly brackets with data in them, or it could be an empty dictionary, such as we see here. One way to create a dictionary is just by creating empty brackets, and that's an actual dictionary, but there's no data in it. So here we see these key, colon separates the key and the value, key over here on the left, and the value right here. So if we want to access the name parth, we would reference name in this dictionary, and I'll show you how we do that here soon. Each entry is separated by a comma, just like with lists, except for, and this is also the same with lists, as I mentioned, the last item. There's no comma after the last item because it's the end of our dictionary. So that is how a dictionary is broken up. And a key is unique and immutable. We cannot have 2 keys in this dictionary called a name. In other words, whatever's to the left of each colon are keys. We cannot have 2 called name or 2 called age, city, awake, etc. We can only have 1 unique key value. That might be a bit confusing how I just said that. We can have only 1 unique key, not value. Values are non-unique and mutable. So we could have any number of values, which would be our entries to the right of each colon. We could have any number of values. They could be the same. Our entire dictionary could have the same value for each entry, each key value pair. And our keys are immutable, meaning we cannot change a key. So there are ways around this, but we cannot say this key should now be called reference. We cannot say that. We can't change that key, whereas values are mutable, meaning they can change. So I could change this 30 to 40 or something else. Let's hop over to another slide where I'd like to explain a little bit about the difference between lists and dictionaries to help us grasp this concept a bit more fully. So over here we have a train on the left and a cargo ship on the right. I like to think of a list as a train. it's sequential from front to back, from beginning to end. This way, it's sequential, and each train car has an item. So here we have an item in the list. Here's another one. And we can work our way through this list or reference a specific train car at some point in the list. But it's an item and it's sequential like that. Whereas a cargo ship, I look at that more like a dictionary, because we have layers upon layers of data and we can reference it any which way. Where what I mean by that in Python is we reference it by name, but we can have data all throughout the dictionary, and we can say, oh, I want to reference this part of the data, or oh, this key value pair over here, or this key value pair over here. And it's not sequential like a train, like I think of a train as being, but order doesn't necessarily matter in a dictionary. So I think of a dictionary like a cargo ship. We can go to a certain row, a certain aisle, a certain height, referencing it by a name or key, where a list we reference by the index. Some other differences between a list and a dictionary. As we've said, with a list, order matters, and order doesn't matter with a dictionary. Lists are more sequential, and dictionaries are non-sequential. And lists are accessed by index, as I mentioned. Dictionaries are accessed by key. So that's a primer, a little introduction on dictionaries, and let's continue learning about them in our next lecture. We alluded to this in our introduction of dictionaries. We will now talk about accessing values in dictionaries. So how we do that is we reference the keys, as we mentioned. So what we do is we declare here, well, not declare, rather, we specify here the name of our dictionary variable. And then it may be a bit confusing, but here, when we're accessing dictionary values, we use square brackets. When we're creating a dictionary, we use curly brackets. When we're accessing dictionary values, we use square brackets. So we have our variable of our dictionary, square brackets, and then the name of the key. In this instance, the name of the key is a string called name. There's another way that we can reference values from a dictionary, and that's with the dictionary get method. And that's used for safe access. So we could say the name of our dictionary variable dot to invoke a method from our dictionary class, and dot get, and then parentheses, name. So that's our key name. So the benefit of using this get method is that if we don't, and our key does not exist, let's say I'm trying to reference a key named Adam in my person dictionary variable, but there is no key named Adam. All we have in this dictionary is a key with the identifier as a name, a string of name, and the value is parth. So I'm trying to say, is there a key called Adam? Well, there's not, so we'll throw an error. But if we use the .get method, it's the same thing as this, except it would return none instead of throwing an error, which can be useful. So I want you to be aware of that. We can also specify if a key is not found. If our key Adam is not found, we can specify as the second parameter of this get function what text we want to return in that instance, what value we want to return. So we can say not found. So if we then try to access the Adam key, which does not exist, we only have a name key, then we'll return the text not found. So that's another benefit of using the .get method with dictionaries. In all reality, probably this is the way that you will, this is the way that you'll probably do it most of the time, but there will be instances where we can use the get method. And when I say most of the time, I mean by using the square brackets and then the value of a key. So let's hop over here and look at an example. Let's create a dictionary, and let's call it zoo. We'll make this a little bit bigger here. Let's say zoo, and then remember not parentheses, curly braces. And then we have our key. Let's call it lions. And then a colon, which will separate our key from our value. Let's say we have 5 lions. And then a comma for the next entry in our dictionary. Let's say, and we don't need a space, however, it's good practice to have a space. We can say elephants. Let's say we have 2 elephants. And I'll make this a bit smaller to fit some more. Let's say we have a zookeeper whose name is Sydney. Okay, so that's our dictionary. Now, if I want to reference, let's say I want to reference this Sydney. How do I do that? By the key name. So we can say print zoo, our variable name of our dictionary, square brackets, and then the value of our key. I know that's confusing how I keep saying that. I do apologize, because we have name value or key value. So the key is what I mean to say there. So let's say zookeeper. I'm going to save this text file and run it. See what we printed out? Sydney. We printed out the value. We could also print the number of lions. I'm saving it, and let's run it again. We see there's 5 lions. Or we could do elephants. I'm just referencing these keys in the dictionary. There's 2 elephants, as we see. So that's how we access elements in a dictionary. We reference them. We reference the values by the name of the key. One other thing I want to point out is that if we have our dictionaries can and usually will span multiple lines. I've done it on a single line for simplicity, but we can also, for ease of readability, I should say, we can hit an enter here, tab things over, hit an enter here, where this bottom bracket lines up with our variable name, and then each element we have indented like that. Remember, the last element does not have a comma, by the way, because there's nothing else to add. So commas in between each element, except we don't have a comma at the end after our last element. So let's see if this gives us the same output. And it does. We're printing out how many elephants there are. So you can see this is a little bit easier to read because we know that each element, each key value pair is on its own line. So we will use that convention a lot. All right, let's move on to our next lecture. Now that we've discussed how to create a dictionary and how to access values from a dictionary, let's talk about modifying dictionaries. So we can add or update key value pairs, and we can remove items. And those are our 2 primary operations with dictionaries. And how we add a new key value pair or modify a key value pair if this job key exists is like so. So the name of the variable for our dictionary, square brackets again, the name of our key. This is always going to be a string, by the way. The name of our key, and then assign that to our value. So here we are assigning it to a string of engineer. If this exists, it will change whatever this key value pair was to now be engineer for the value. If the job key does not exist, it will create a new key value pair with the key being job and the value being engineer. And we'll look at an example of that. And we can remove items from a dictionary with del for delete or pop. And I'll show you some ins and out of these methods here in a moment. Here's an example. If we have a person dictionary, the name of the variable is called person. And we have a key called name with its value, a key called age with its value, city, and awake, etc. So if we change the name key value pair, so we're referencing the name key, we're changing it to Jenica. And then we print it with it referencing the name key. We see that it references Jenica now, and it has changed. If we print our person dictionary, the difference here is the name value has changed from Parth to Jenica. Let's look at a few more examples, and we will open up idle for this because it's a little bit easier to demonstrate. Let's create a new dictionary, rather. So let's say inventory, our curly braces. Let's say apples, 100, colon, 100. Let's say bananas, 200. Okay, this is our dictionary. And now, what if we want to create a new key value pair? We can say inventory. Let's say strawberries. Let's say we have 50. Now, if we print our inventory dictionary, we see that strawberries is also included there now, along with apples and bananas. Let's say somebody buys some strawberries. So we want to change that value. So we reference it with the square brackets. I should have picked an easier word to spell than strawberries, but this works. And let's now say that it's 49. Because somebody bought one. See, now our dictionary has 49. So we just changed the value of our strawberries key. Just like that. Just like that. Now, if we want to, and we've also added, as we saw, a key value pair, just like that. Let's say we want to delete a key value pair. Let's delete strawberries. Let's say someone comes in and they buy all of our strawberries. You know what? I'm going to say apples because that's easier. Del. And then we reference the key. Remember, this is all about referencing the key. Whoops. Inventory is our variable name. Now let's look at our inventory. We see apples. That key value pair is gone. What if I want to return the key value pair that I'm deleting? Well, we can use the pop method. So we can say inventory.pop and then reference our key. Let's do bananas this time. And let's set that equal to a variable. Let's say bananas bought equals inventory.pop bananas. So we're going to remove the key value pair where the key is named bananas. We're going to remove this. Now let's see what bananas bought is. Print 200, because we just assigned that, we've returned that variable or that value to our bananas bought variable. So del is a great way to delete a key value pair by referencing the key. Pop is another method on our dictionaries referencing the key that will also return. We can return it to a variable if we want our key value pair, our value rather, as we see there. One note about the difference between delete or del and pop is we should use del if we know that the key exists, if we are 100% with zero doubt that the key exists. Otherwise, if the key does not exist, it will throw an error. If we want to avoid that, we can use the pop method, and we can specify if the key does not exist, what to do. So let's say we want to inventory.pop, and I do not have a key called milk. What will happen here? We get an error. But if we try that again, and I'm going to reference a key that does not exist as well, but put another parameter into this function to be returned when I don't have a key called milk. And then if we hit enter, then we won't throw an error, but we'll return our value here. So a little difference between del and pop that I wanted to share with you. And let's move on to our next lecture. Let's talk about dictionary methods. And these are some built-in useful tools that we can use with our dictionaries. First of all, remember dir and help. We're going to review these briefly because they're so useful and can help us see which methods are available with our dictionaries. And then we're going to talk about a few methods that are very useful. The keys method, which retrieves keys, the values method, which retrieves the values in a dictionary, and the items method, which retrieves both the keys and the values. So let's hop on over here to idle. And there's a reserved keyword for each of our dictionary data type, and it's dict, just like list has a reserved keyword. And if we say dir on dict, so the dictionary data type, that will show us these attributes and methods of our dictionary class. There are not a ton of methods in our dictionary class, but there are several. And I'd invite you to look through these at your leisure. We could look through by going to help. You could say dict dot get, and it will tell us a little bit about the get method. We could replace dict with an actual variable. If we had a variable that was my dictionary equals such and such, we could put my dictionary here instead of dict as well. So I'd invite you to peruse those, but wanted to just remind you of the dir and help methods in Python. Very useful for our data types. So now let's talk about, going back to our slide, these three important methods: keys, values, and items. And as we see here, if we do person.keys, and person is our dictionary variable, then it will return the key names here. So each of these represents a key. And if we do person.values, that will return our actual values, which are here. And if we call person.items, that returns both the keys and the values. And each one of these inside parentheses is our key and value. So let's look through an example. Another key, another value. Let's look through an example of that. So let's say a new dictionary. Let's call it car info. We'll create a new dictionary. So color of our car, we'll say, is red. And the year of our car is, let's say, 2010. And we'll leave that as an integer for now. We're not going to enclose that in quotations to make it a string. We'll leave it as an integer. Sure, why not? And let's add one more for our make. And we'll say it's a Honda. I love my Hondas personally. So now we have our dictionary called car info. And what if we do carinfo.keys? What do you think it will do? Let's try it out. We see it returns color, year, and make. Color, year, and make are our keys. We can do the same. Carinfo.values, red, 2010, Honda. So we got our color, our keys. Now we have our values. And lastly, carinfo.items returns both. And we'll talk through in an upcoming lecture about how we can access all these values using these various methods. That is it for now. See you in the next lecture. Iterating over a dictionary is very important, just as we iterate over a list, also very important. So we're going to learn about that. There are 3 methods that I want you to be aware of, and all of them involve using a for loop, which we teased when we iterated through our lists, and we'll continue to tease a bit more as we iterate through our dictionaries. And later on in the course, we'll deep dive into for loops and while loops and how they work. But for now, I want to show you how to iterate over dictionaries using for loops. And what that means is how we can hop over each element in a dictionary and access them. So these 3 methods are for key in person, or where person is the name of our variable, or for key in person.keys. So persons are our dictionary variable. And either one of these will work. I'd suggest you just use for key in and then your dictionary. It's just a little more simplistic, but that will iterate over the keys in the dictionary. If we do for value in person.values, that will iterate over the values. And a reminder, this is the same as lists. Key and value, they're just arbitrary words I've chosen. Those could be anything that you choose to. It's just within the loop. As we get to the loop down here, within the loop, we will reference whatever we have called them. So we'll reference key and value. So you can choose whatever names that you'd like. And then lastly, iterating over key value pairs. We can say for key, comma, that's important, otherwise we'll get a syntax error. Value, and again, these can be any names that we want in our dictionary variable name dot items. That will iterate over our key and value pairs. as we see in this example. For key value in person.items, print the key and the value. And that has printed the string key with our key, our keys, the names of our keys, and we've printed the string value as well with the names of our values. Let's look at an example together, and we'll come back here to our zoo dictionary that we have seen previously. So if we look, let's try each of these. Let's try iterating with each of our methods. Let's iterate through the keys. So we can say for, I'm going to call it something random, just to demonstrate a point. For stuff, well, we won't make it that hard to interpret. For my keys, there we go. I'm calling it something that's a little bit descriptive, but also just not keys. So you understand that this can be, this for loop variable here, this local variable can be whatever we'd like it to. For my keys in zoo, we could also do in zoo.keys, but I recommend you just name your or reference the name of your dictionary. We can access those. So let's just print my keys. And this would be my key. This is not going to be plural because we're iterating, and for each iteration, we're going to just print one for each iteration. So let's save that file and run it here. And we see we've printed out the name of each of our keys: lions, elephants, zookeeper. Let's change this up and say for, we'll go back to some more kind of conventional naming. For value in zoo.values, let's print value and save, and then run our script. And we see we've printed our values, 5, 2, and Sydney. And now for our last demonstration, for key value in zoo.items, let's do something a little fun here. We could just do print key and value. Let's try that and give it a go. We have printed our keys over here and our values over here. But what we'll generally do if we're using a loop like this is we'll want to do something with our data often. Sometimes we'll just want to see it. But let's print key, and we know our keys are always strings, so let's print key dot. Let's use one of our string methods. If remembering from several sections ago, let's do key dot capitalize. Let's see what we can do there. So we're modifying it a little bit. There we go. So we've capitalized lions, elephants, and zookeeper. Or we could do something like upper. Run it again. And we've made them all uppercase. So that's a demonstration for you of iterating over dictionaries. And we will end there with this lecture. All right, last thing we're going to talk about with respect to dictionaries for now is nesting dictionaries. If you recall, and I love repetition for learning, we did talk about nesting with lists, where we can have a list within a list, or lists within a list. And we can go on and on. Well, we can have a dictionary or dictionaries within a dictionary. So let's take a look at that, because this is actually going to introduce to you some things that will be very helpful with our project that we're going to do after this lecture. And that project will be on something called JSON, which is a way that we can represent a lot of data. And it's very useful, it's very human readable, and it's a very good skill to know, not just as a Python developer, but as a person in the tech world. So this will be a good introduction to that JSON project that we'll be doing. So here we have a dictionary variable, our team, and that's assigned, open curly bracket, close curly bracket. These two keys here, player 1 and player 2, with their associated values. Remember, so we've got a key and then a colon, and then everything to the right is a value. After that value, we have a comma, just as review. After the last value in our dictionary, there's no comma there. And that also applies with JSON, which we'll get to, as I said, very soon. So key, value, and our value in this instance is another dictionary. Key, value, comma, key, value. That represents that dictionary. So if we have a nested dictionary, we can access the nested dictionary keys and values by referencing our dictionary variable and then square brackets to reference our key. So we're referencing the player 1 key, and then another set of square brackets just right after the first set to reference another key, this name key of our new dictionary. And as we can see, if we run that script that I've got here, it will print out John, which is the value of that name key. So let's look at that in practice. We've got the same thing defined here. And if we run it, we see that it indeed prints out John. So let's get a little bit more advanced and add another element to our team dictionary. So since we're adding something else to our team dictionary, we're going to put a comma here after our last element because it's no longer the last element. Let's add another key called team info and add another dictionary there. And we'll just create some basic data about this team. Let's say team name is Chargers. And I'm going to expand this a little bit for your sake to see. And let's add one more element. Let's say team city. And we'll call that Tokyo. Okay. I have made a mistake. Did I delete? I totally did. I deleted all this right here. Let me copy that and redo everything I've done and paste that back down below so we can print some things and end our dictionary. So that closes the dictionary right there. Now let's print, if we want to print the team name, the value for the team name. So we want to access the value for our team name. What's our team name? Well, it's Chargers. So think to yourself, how could we access this Chargers value? And you can pause the video if you'd like and think about that. All right, so let's do that. Let's access Chargers. So we have team, our dictionary, which has 3 keys, player 1, player 2, and team info. If we want to reference this dictionary, we need to reference it by the team info key. And then to reference this value of this dictionary, we need to reference the team name key. So let's save that, Command S, and run our script. And we've done it. We've printed out chargers. So that's a good overview of nesting dictionaries and a great precursor to our JSON project, which will be coming up next. I'm excited to go through that with you, and we'll see you soon. All right, I'm excited for you guys to learn about JSON, and we're going to learn about it and do a project in JSON. So what is JSON? It stands for JavaScript Object Notation, and it's not a Python construct, but it is something that Python is very good at working with, at creating JSON and reading JSON. And what it is essentially just data representation that's easy for humans and computers to read and write. So this is an example here of some JSON data. And we see that it looks like a Python dictionary. And for the most part, it is structured very similarly. One difference, knowing that it is not Python, is that our data types are different. So our Booleans are not going to be capitalized because this is JavaScript, not Python. And that's the main thing that you need to understand of the differences. However, when we convert JSON into Python, we use a library called the JSON library, and that takes care of that conversion for us. So again, it's just data representation. It's just a way of organizing data into this format that's easily readable and easy to work with. It's very useful to know, and especially as we start working with things like RESTful APIs and pulling a lot of data or information from a system, often it will be formatted in JSON. So we do need to know how to work with it, and this will be a very useful project for you to add to your toolkit. Okay, here we have various methods that we can use with JSON that we'll use for our JSON project, and some tips that will help you. So as we see here, there's 4 primary methods that we use with our JSON module. And once we import this JSON module, I'll show you how to do that. In other words, make it usable for our Python program. We can then use these methods. So we'll call them the module, we'll call that JSON class dot, and then one of those methods defined within that JSON module. So these 4 methods are what we'll be using, and the first 2 here, load and loads, they will convert from a JSON file or a JSON formatted string to Python dictionaries. And the other one of these, the other 2 of these, is the dump or dumps methods, which convert from a Python dictionary to either a JSON file or a JSON formatted string. The way that I remember this is if load or loads or dumps, if it has an S at the end, think string. So load, string, or dump, string. And if it does not have an S, then don't think string. So it would be some file or file-like object that we're either loading from or dumping to. So these are the 4 methods. I did highlight prior as well that JSON is not a Python construct. It's JavaScript. However, Python's very good at using it. So remember that these data types in Python are converted to JavaScript types into JSON. You don't really have to worry about that, except just note primarily that Booleans are not capitalized in JSON, whereas in Python they are. So that's probably the primary difference you have to worry about. And we'll highlight some options here. I may not get into all these very much, but I will show you in the summary text after the lecture some useful things to know about working with JSON. So let's get into our project. What I've got here is a few files. I've got a data.json file. .json is the standard way of naming these files that contain our JSON data. And I have here some JSON data. And then I've got a Python script with some comments to help us out. I've imported the JSON module. We always need to do that if we're going to use these JSON methods. So I've imported that at the top of my script. And then over here, I've got a terminal. And if we just do ls, we have two files within this folder. Our script and our JSON are located in the same folder, so it makes it easy to run. So for our project, what I want you to do is create a JSON, some JSON data similar to this that tells us a little bit about you. And by us, I just mean in general. That just would tell someone a little bit about you. So for example, I've created my name, age. I'm not a student currently. I'm married, some interests, favorite movies, contact info, languages spoken, has driver's license. So I've just picked some arbitrary information and I've filled in that about myself. I've put this in its own file, data.json. And so I'd like you to do the same and pause the video here while you fill out some information about yourself. And you can include whatever you'd like. You can include or exclude any of this information, or other information that you think is relevant. If someone were to try to get to know you, you could share this JSON file and they would have a pretty good start. So why don't you go ahead and do that? If you'd like, I'm also going to just type through a few of these, these bits of information as well to highlight a few key points about creating JSON. So first of all, let's say we're creating a new file. We want to start with our curly braces. So open curly brace, close curly brace. And then it indents automatically for us. And here we can create a key. Think Python dictionary. So we could say name, that's a key. And then colon separates our key and our value. Colon space. Joseph, it's a string, that's why it's surrounded in quotes. Comma after every element in our dictionary. Same with JSON. There's a comma at the end of every line or every data point, unless it's the last data point in its section, if you will. If it's the last data point in a list, or last data point in a dictionary, or last data point in our JSON entry. So if this were all I had in this JSON, I would not have a comma if there were only one entry, because it is in fact the last entry. But let's add a few more things. So I'll put a comma there. Age, this is another key. We've got an integer, I'm 35, at least at the time of this recording. Who knows how old I'll be when you view this video. And let's say interests, and let's make a list. So we could do a list just like this and say sports, tech, etc. But it's also a bit easier to read if we create our open square bracket and then hit enter. And we see that our closing square bracket should line up with the beginning of our variable. This is helpful for when we're creating JSON or dictionaries or lists or these longer data types. It helps it be readable. And then I'm going to tab indent there to make it readable. And here I can create my data. So let's say sports, let's say tech, and we'll leave it at that. But I'm going to put tech on its own line. There we go. That's a bit more readable. We could add more. So interests, this is its own entry. So I need a comma at the end of our interests list. Okay, now we have a new entry, a new key. We could say education. And let's make this a dictionary. I'm just trying to highlight again and walk through the process of creating data like this, because it's something that was a little bit trickier for me to grasp when I started learning about it. So I'm just trying to walk you through that process. So for creating a dictionary, let's open curly bracket. We could do it on the same line. However, for readability, let's hit enter. So then we'll tab in and start our items here. So we'll say, I'm just going to put elementary, like what was the name of my elementary school? Osmond. That was the name. So we've got our key value pair here. The name of our dictionary is education. And I know this might be a bit confusing. This is not a Python dictionary, but it will be when we bring it into Python. This is simply JSON. Let's have another variable. So I have that comma again. And we'll just say graduated. And let's make it a Boolean, true. However, since it's JSON, lowercase true. Because it's JavaScript, it's not Python. And I don't need a comma here because it's the last element in the dictionary. I also don't need a comma here at the end of our dictionary definition because this is the last item in our JSON. Or it would be the last item when we convert it into Python in our dictionary. So I just wanted to walk you through that. Now, if you haven't already, feel free to pause the video and fill out some information about yourself. You can look at this for examples, and we will be right back and continue on. All right, we are back. I hope you've been able to create some JSON for yourself to describe yourself a little bit. Now we're going to work with it. And this will be a great tool to add to your skill set, working with JSON. So here we have some methods. We're first going to work with the JSON.load method. Then we'll talk about loads, dump, dumps, and I'll show you another way to print to print dictionaries that's easily viewable. So first of all, let's do load. We're going to copy this here, and it's a way to read JSON from a file into a Python dictionary. Remember, we have to have import JSON at the top of our script. I've got the name of the JSON file, data.json, and I have that saved here. And we're going to open the file as a file. That's the name of this file object. We're going to create a variable called data and then load the JSON data from our file, and then we'll print the data. So let's try that. Okay, we see it printed our data. Now let's also do type. Let's print the type of data. Let's save that and run it again. We'll see that it's a dictionary. It's of class dict, which is a dictionary. So I wanted to highlight that. We bring it in from JSON. It turns it into a dict. So also you'll notice our variables, our Boolean variables were lowercase in JSON. Well, in our dictionary, the JSON module has taken care of converting them to uppercase for us so that it is proper Python syntax. So our JSON module does that behind the scenes. So that is the load method. Again, from a JSON file or file-like object to a Python dictionary. We can also load S, remember, think S for string, from a JSON formatted string to a Python dictionary. So let's bring that over here into our script. And all that is meant by JSON formatted string is essentially JSON encapsulated by quotations within our Python script. So here's a JSON string. See, we have triple quotes, and that denotes a multi-line string in Python. I'm going to copy all of my JSON there, except for, no, that is perfect. So that should work. Let's save that. And then what we're going to do is load it from a string and then print the data. So we could have a JSON string here. So let's clear and let's try running this again. There we go. So we get the same output. It's a dictionary again, just a Python representation of our JSON. So that's loading from a string, from a JSON string. Now, thirdly, let's do JSON.dump. And this is for a dictionary, a Python dictionary to a file. So we're going to put this right here. And we need to represent our data. So this is going to be a dictionary. So I'm going to copy the contents of this here. I'm going to hit enter so it's a little cleaner to read. Paste it in. And I need to change these variables because I want it to be a Python dictionary, not JSON anymore. So I'm capitalizing these. And then what I'll do is I'll just name it data2.json so we can see this in action. So I'm saving that. And what this will do is it will take our Python dictionary and open a data2.json file. As file, that's our variable name. And then it will dump our dictionary into a JSON format with an indent of four spaces for each of these indentation levels. That makes it a little more readable. So let's make sure our file is saved. And I'm going to do an ls and show you we just have these two files present in our current directory. But if we run our script, we see nothing. I've not printed out anything here, but it should have created this data2.json file. So if I list ls again, we do see a data2.json file. And if I open that up, we see there's the data that it's written. And it's written into JSON. You can see one easy way to tell is these Booleans, as I've mentioned. They're all lowercase now. But in my Python, they are capitalized. So the JSON module takes care of that for us. I've just opened this with the Vim text editor, which is an easy way on Mac and Linux to view files that I really like. So that takes care of our dump method, which goes from a Python dictionary to a file. Let's now look at our JSON.dump s. Remember, when you see that s, think string. So it's from a Python dictionary to a JSON formatted string. So we'll keep it within our Python program. I already have my data variable, and I'm just going to clean this up a little bit to highlight what we're doing. There we go. So we have our data dictionary still. It's Python dictionary. What we're doing is we are dumping it to a JSON string. And we are also setting that indent to 4. We could also set other values, as I've mentioned, such as, going back to our slides, we could sort the keys in sorted format if we want. And we can change the kind of separators that are used, such as colons, commas. So there are some attributes we can change if we so desire. I just wanted to point that out. But all we're going to do here is indent 4 to make it readable, and then we'll print that string. I want to also show you what happens if we don't use indent 4. So let's save it, clear our screen, and run our program. So there we go. There's our JSON. And So that's just from a Python dictionary to a JSON formatted string. So if we actually print the type of this JSON string variable, let's see what happens. I'll run that again. We see it's a string now. That's what our resultant JSON string is. What we can also do is let's remove this indent 4 and run that again. So we see it's less human readable now. So that indent 4 is very useful when we're working with dumping our data or putting it into JSON format. Now, lastly, another way I just thought would be interesting to you to view our dictionaries in Python is a module called pprint or pretty print. And JSON is one way that we can view a dictionary in a pretty format or a viewable format by dumping it to JSON and having this indent equal 4 spaces, as we just saw. But we can also use something if we don't want to do that called pretty print. So I'm going to import pretty print in my script up at the top as well. And then we can just do pretty print or pprint.pprint. We're calling the pprint method from our preprint module. And let's just replace that here. So we're just wanting to print this dictionary. Now let's see what that does. I've saved the file. Let's run it. So we see it pretty prints it out as well. It's a little bit easier to read with our keys here on the left and then all of our values following. So that's our project. Now you have equipped in your tool set being able to work with JSON in Python. So I hope that was useful to you. I know it will be. I know it will come in handy for you. And we'll see you in the next lecture. Let's talk about a few remaining data types that we haven't discussed yet. And these are the last data types that we'll explicitly cover in this course. And those are sets, tuples, and NoneType. Let's begin with sets. Sets are an unordered collection of unique items. So there are no duplicate elements in sets. They can contain mixed data types. We have an example set definition here. Our variable mySet is assigned curly bracket. And then we have various types of values, integers, floats, strings, and closing curly bracket. And we see that we can contain those mixed data types. This looks like a dictionary a little bit in the sense that we have the curly brackets. So you might be used to thinking, oh, dictionary with curly brackets. However, you'll notice there are no key value pairs separated by commas. It's just values separated by commas. So that's how we know we're defining a set. That's how Python has defined this construct for us to use. And that's how we can define it, how we can create a set. We can, as we have talked about, use those curly braces. Also, we can use the set function to create a set. And there's a few useful operators. These methods are add, where we can add the integer 10 to our set if it doesn't exist. If it does exist, it will not be duplicated because there's no duplicates. We can remove a value. So if the integer 10 here is within our set, it will remove the integer 10 from the set. If it's not in the set, it will throw an error. So there's a way to work around that where we can just check if 10 is in the set before we remove it. I'll show you an example of that here in a minute. And we can also update our set, which takes in an iterable, multiple values, and adds those values to the set. And what I mean by iterable is a data type that can be iterated over, such as a list or a string. We can iterate over each index position and pull those values. So the update method would pull each character from a string, for example, if we put a string in here, and add all those characters as separate items in a set. And we'll look at an example of that. We cannot access items in a set by index because the set data type is unindexed. So we can't say, as we can with lists, our list item in the 0th position, let's access that. We can't do that with sets because they are not indexed, but we can loop through them with a for loop. And some other set operations are, if you've taken some advanced math, you know about set operations like union, intersection, difference, and there are those methods available for sets as well. All right, let's come on over here to idle and define a set. So our curly brackets, well, let's put 1, 2, 3. Let's put some strings in here. Apple, banana, and close our set with a closing curly brace. So we've defined a set, and let's add to our set, myset.add, let's add 100, the integer 100. Now if we print my set, we see that we've added 100. As we said, this is unordered. It will just insert it into any location there. We could remove an item. Let's remove the integer 3 and print my set again. We see that 3 is no longer there. What if we try removing an item that's not in the set? Let's say 1,000. Well, that's where we get an error. So what we could do is a simple if statement. We could say if 1,000 not, actually if 1,000 in my set. We're testing for membership. If 1,000 is a member of my set, if it's an item in that set, then we could say my set.remove 1,000. And nothing happens because it's not in my set. So we see my set is still unmodified as it was before. We can look at the update method. So let's define a string, say hello, and then use our update method with that string. And let's see what our set looks like now. So we've added each character of this iterable, this string, which is an iterable, so HOLE. And what you'll notice is that there's only one L in our set. However, our string had 2 L's. Now, that's because sets are do not contain duplicates. So that's why we only have 1 L. So a nice demonstration there of how elements in the set need to be unique. And that's what our update method can do, is add items from an iterable. We could also say my list equals 1, 2, 3, 4, 5, and do the same thing. My set.update my list. So we're taking this iterable list and using the update method on our set. And let's see what happens here. We see we already had 1 and 2, 1 and 2 in our set, we've added 3, 4, and 5 to our set from this list. So another example of the update method. Lastly, I want to show you what would happen if we tried to access by index. Let's say print my set 0th index. That doesn't work. It's not subscriptable is our error, but we cannot access by index. But we can use a for loop. We've introduced for loops a little bit in the course, but we could say for item in my set print item. And we see we can print out every element in our set. So those are just a few things we can do with sets, a little context about them and how we can use them. Tuples are a data type we will definitely encounter in our Python programming journey, whether we perhaps recognize it or not. So let's spend some time talking about tuples. They are an immutable, in other words, unchangeable, ordered collection of items. They can contain duplicates, and they can also contain mixed data types. So they will preserve the order. So here's an example of a tuple variable defined with 2 values. They can contain many values, but we have 2 values. And this value will always be the first value. This value will be the second value and last value. We cannot change this. If we try to change it, we can't. And so that has some benefits for programming. Which it makes them useful for representing fixed collections of items, such as you can see, a coordinate that would never change. So we could potentially store coordinates in a tuple, for example. And they're defined by enclosing these elements in parentheses and separating them with commas, just as we see here. So Python sees that. It sees these parentheses. It sees values separated by commas, just like this. It knows that's a tuple. Since they are immutable, since we cannot change these values, then there's not very many methods really to work with. There's the count and the index method. And if we want to change the values in a tuple, what we can do to work around this, if we need to change them, is we could convert to a list and then modify and then convert back to a tuple. So for example, here we've got a couple examples of that. On the left, we've got our tuple, apple, banana, cherry. We convert that, we typecast that to a list, and we assign that the value of the y variable. Then we say, okay, the index position 1, change that to kiwi, and then convert it back to a tuple and print that, and it prints apple, kiwi, cherry instead of apple, banana, cherry. Same over here. We could append an item, an orange at the end of this list, this tuple, after we convert it to a list, and then change it back to a tuple, and it will now be apple, banana, orange. So something interesting to note. There's also something called packing and unpacking a tuple. You'll hear these terms along your Python programming journey. Packing a tuple just means essentially creating a tuple, adding values to a tuple, which creates a tuple because as we have discussed, it's immutable. So creating a tuple is the same as packing a tuple. Just different ways of saying it. Unpacking a tuple occurs when we assign variables to the values of a tuple. So we have our tuple called fruits, and we have apple, banana, and cherry. Well, what we could do is we could say, I have 3 new variables, green, yellow, and red. These are the variable names. And we're going to assign that to the fruit tuple. So apple will now be the value of green, the green variable. banana will be the value of the yellow variable, and cherry will be unpacked into the red variable. So if we print these, we'll see that that's the case. Print our green variable, which is apple, yellow variable is banana, and red variable is cherry. Let's just look at a few examples here. We can say my tuple equals red, orange, green. And let's look at dir my tuple. We see there are only two methods available. To help my tuple.count, we can input a value and return the number of occurrences of that value. So we could say my tuple.count red. There's one occurrence of the letter red. The color red. And let's do my tuple dot help my tuple dot index. Return the first index of a value and raises value error if the value is not present. So let's say my tuple dot index of red, and it is in index position 0. Tuples are indexed, unlike sets, so we can access them by index. So if we scroll up here, we see red is in the 0th index. So let's try printing my tuple 0. And we see that prints red. So those are just a few examples of working with tuples. I wanted to spend 1 or 2 minutes on just some comparisons of lists, sets, and tuples, because I think they're very similar. They seem very similar. However, they're different enough to talk about. So if you'd like, you can pause this video and review this table that I've created, which has differences and similarities between lists, sets, and tuples. Some things that I'll point out are ordered, mutable for lists, and they can change, but they preserve order. Sets are unordered, they can change. Tuples are ordered, they cannot change. The syntax of creating them. Are duplicates allowed? If you don't want any duplicates in a variable, use a set. If that would be an easy way to make sure there are no duplicates. They can all contain mixed data types. Sets do not support indexing. There's various use cases for each of these with some examples. Lists have a ton of methods that we can work with. The others don't have a whole lot. They're more narrow use cases. Some notes about performance, and again, mutability or immutability. So I wanted to share that with you briefly and just give you a chance to soak that all in. Some similarities and differences between lists, sets, and tuples. Okay, there's one data type that's a little bit interesting, but is a concept in programming we need to be aware of and familiar with, and that is the none type. None and NoneType in Python. Often this value is called null. It's the absence of a value. So it's not the same as an empty string or 0 or false. It's really to denote that there's nothing there. And there's no value at all. So what that is called in Python is none. It's a reserved keyword. We could set it equal to a variable if we desire. And if we print the type of that, it will output none type. So none is what represents the null value or absence of a value. And NoneType is the type of none. One interesting thing in Python, none is a singleton, meaning there's only one instance of that in Python. So just wanted you to be familiar with that. We'll run into this here and there throughout the course, and all it really means is that there's no value defined. So we'll see this in error outputs and other things like that. So wanted you to be aware, and that is none and NoneType. We're now going to talk about something called conditionals, specifically if, elif, and else in Python. And these are a very powerful control structure that allows us to run different code based on certain conditions. If a condition evaluates to true, we can run some code. If it evaluates to false, we'll run some code. So it's a on-off kind of thing. True, false, yes, no. And we have a lot of real-world applications that we can compare this to. For example, here in America, the stoplights are red, orange, and green. They have 3 colors on them, usually. So we could map this out in Python, and we could say if the light is green, go. Otherwise, or else if the light is orange, slow down. Otherwise, stop, assuming that the light is red. And here it is mapped out in Python. If, elif, and else, these are reserved keywords in Python. We cannot assign them to variables or use them in other situations besides using them as these control structures. So if, you see that's a different color because it's a reserved keyword. The light color variable, we'll assume we have a light color variable defined up here in our program somewhere. If the light color equals green, then keep going. We'll set that an action variable, assuming that's defined in our program. Otherwise, or elif, this is how that otherwise condition is set in Python. Light color, if light color is orange, then set our action to the value of slow down. And finally, if no other conditions match, else set the action to stop. We could also interpret this and say, well, what if the light's broken? We could say elif light color is orange, do its thing. Elif, we can insert another condition in there right here. Elif light color is red, then stop. And then ultimately we could say else, which is our catch-all condition. If none of the above conditions are true, if they don't match, then else. Then we could say else, well, stop, something's wrong. The stoplight is broken. So that's a brief introduction to our if, elif, else control structures that give us a lot of added power in Python. Let's dive deeper into our if, elif, else control structures so we can better understand how they work and when to use them. First of all, the if statement. This executes code if the given condition is true. It's always a true-false deal. Yes, no. And so if a condition is met, run some code. A real-world analogy is if it's raining, take an umbrella. And the Python equivalent to that would be we could create a variable called umbrella needed and assign it the value of false or Boolean false. We could create another variable called is raining and assign that the value of true, saying, oh, hey, it's raining. Then we have our control structure, our conditional if is raining. So is raining does indeed evaluate to true because it is raining is true. Then an umbrella needed is true. So we'll flip the value of umbrella needed from false to true. So that's a simple example of how we would do this in Python. And a few things to note here, just with the syntax of our if statements. If is a reserved keyword. We cannot use it for anything else. Otherwise, Python will throw an error. But if we use it in this condition mechanism, we start out by saying if, and then everything that proceeds after that will be our condition, which will either evaluate to true or false. And we've learned about truthy and falsy values. This condition could be, we could say if, and then put a list there, a list variable. If that list variable has contents, that's truthy, so it would evaluate to true. If it's an empty list, it would evaluate to false. So lots of things that we can do with this condition, but ultimately it's either true or false. And then following that condition, we have our colon. Always, we always need that. That's just how Python has defined this mechanism. And then we need to indent 4 spaces or a tab to match the rest of our Python code. And then it will run this code that is indented if this condition is true. We could have many, many lines of code underneath here. All of them would be indented the same level if they are all to be run under our if condition, if they are all directly under our if condition. They could be indented further under other circumstances as well. But none of them, if they need to be evaluated under this if condition, none of them would align up here with our if keyword. They all need to be indented at least one level or further. That's how Python knows whatever's to be run in here is part of this condition. So under this circumstance, run this code. Let's continue on with our else statement now. So the else statement, I want to talk about this right after our if statement, because a lot of the time we will see an if-else scenario. So if a condition is met, do something. Otherwise, in all other conditions, do something else. And that's what our else statement gives us. It executes code if the preceding condition or conditions were not met. In other words, if they were all evaluated to false. In this example, we have a condition. So if this condition evaluates to false, then we will execute the code underneath our else statement here. We'll execute that code. A real-world analogy would be if it's raining, take an umbrella. Otherwise, wear sunglasses. So just a simple analogy, may or may not, be 100% accurate, but I hope it can help you understand that we're just saying in every other instance, wear sunglasses. So the else needs to match with the indentation of our if statement. So you see if and else, they're both indented the same level. And we'll indent under else the same way we would indent under if, matching our indentation. 4 spaces or a tab by default. And then we will execute that code. So that's a little bit about the else statement. Moving on to the elif statement. This, another reserved keyword, checks additional conditions if the previous conditions were false. For example, if it's raining, take an umbrella. Else if, and then we have another condition that it needs to match. It's windy, wear a jacket. Otherwise, all other conditions, wear sunglasses. So the if it's raining, that would match this. If it's raining, take an umbrella, the code for that. Else if it's windy, condition 2, let's say it is windy, so that's true, wear a jacket, the code for condition 2. Otherwise, under all other circumstances, execute this code, wear sunglasses. So as we can see here, these are all lining up. The if, elif, and else at the same level of indentation. The if and elif match a condition, whereas the else has no condition because it's like our catch-all. It's saying all other circumstances. Elif, this code that's indented under elif directly underneath, will only be executed if everything above it executes to false. If every other if or elif statement above it executes to false, then it will potentially execute as long as the condition also matches. The else will only evaluate if everything above it, all if and elif statements, evaluate to false. Otherwise, it will not evaluate. So we're going to definitely show some examples of this coming up. I will show you some examples and help solidify these concepts. It may be a bit confusing until we see some more use cases. But I think in time and with repetition, it will sink in for you, and you can see that it's a very powerful tool in Python, these if, elif, else control structures. One last example here before we jump into a bunch of examples with conditionals. And that is that I want to show you some operators that can be used to enhance our conditionals and our logic here. These operators are or, and not. They allow us to use multiple conditions for a single statement line. For example, this if statement line, we can have multiple conditions. So let's first talk about the or operator, and where that means that either condition must be true. So if it's raining or is chilly, if either one of these is true, they don't both have to be true, just one of them, then this code underneath our if statement will execute. We could have as many ors here as we want. As long as one of them is true, then we'll hop into this if statement code. And it's the same with elif. We can have multiple operators with our elif statements. And means both or all, if we have more than two, conditions must be true. So, for example, if the time equals 7 a.m. and it is a weekday, then we'll execute our code under our if statement. Let's set alarm. Set that to true. However, if it is a weekday, but the time is not 7 a.m., if this is false, if this evaluates to false, this expression, we will not execute this code. Or if it's a weekend, so if this code evaluates to false, we still will not execute this code. So both conditions must be true when we use this and. And again, we can have multiple and operators. And lastly, not means subsequent condition must not be true for it to evaluate the code underneath. So if not number equals 5, let's take a look at this. If number does equal 5, let's say we have a variable called number and it is 5, well then our condition is saying if it's not number equal 5, execute this code. So this code will not be executed if our number is equal to 5. It will be executed if our number is not equal to 5. So it essentially just negates whatever. It's a way of negating a condition. So number equals 5 equals true, throw in a not, then this expression will equal false. If number equal 5 is false, throw in a not, then this whole expression will be true. In which case, if this expression is true, execute this code. So that is an overview of our or, and not operators, which further enhance our abilities to execute Python code with these conditionals and to customize them even further to what we desire. Let's go through several examples of our conditionals here, our if-else or if-elif-else conditionals. So we have example number 1. I'm going to paste this into a file called myscript.py, as we've been doing. And what we're saying is we're assigning the value to x, our variable x, of an input. We've learned about this previously. The user can interact and input a value, asking the question, what is x? And we are typing that into an integer, the value of x. So, or casting that into an integer is the proper term. So then we're saying, we're using our conditional here, if x mod 2 equals 0, then print our number is even. Else print odd. Our number is odd. I teased this earlier on in the course where we could use the modulus as we were talking a little bit about numbers and arithmetic to do this operation. And now we're actually seeing it in practice because we've now learned about our conditionals. So let's save that and then run our script. So we are prompted with what is x? Let's put a number in. Let's say 15. Well, that's odd. Let's try it again. 20, even. We could go on forever. 100, even. 101, odd. So we can see with our if-else conditional here, we now have unlocked a very powerful Python feature, and we can check if a number is even or odd. Let's move on to our next example. Here we are also using inputs, and we're just assigning to a variable called weather the user input of enter today's weather, and we're asking them to input sunny, rainy, or snowy. If our weather variable equals sunny, then print wear sunglasses. Else, elif, our weather variable equals rainy, print carry an umbrella. Elif weather equals snowy, print wear a winter coat. Otherwise, in other words, all other circumstances or all other input, print invalid input. Make sure to choose one of these options. So let's save that file, clear our screen over here, and run it. Well, I'm going to input sunny. Well, it says wear sunglasses. So that matches this condition. We can do it again. Rainy, carry an umbrella. That matches our second condition. Snowy, wear winter coat. That matches our third condition. Well, what if we accidentally have a typo and say snow? Well, let's use that as valid input. So it has to match exactly our strings here for this expression to evaluate to true. It has to match exactly. So that's another example. Let's look at example 3. As you can see, we're getting some very real-world use cases here that we can actually apply. And here, and actually do some cool things in Python. So here I'm going to assign to a score variable casted to a float, so a decimal number. The user input of enter your score 0 to 100. And then we have a breakdown of if the score is between these ranges. So if the score is greater than or equal to 0, or if 0 is less than or equal to the score, and score is less than or equal to 100. So if they are actually inputting the proper parameters. of 0 to 100. Then, and we see we have nested conditionals here, as we discussed in a previous lecture. Then we run these condition tests. After these condition tests have been run, we'll print a grade. However, if the score is not valid, if it's not between 0 and 100, we'll execute this else condition, which says invalid score and ensures between 0 and 100. So this is a good use case of nesting our if statements. And then we have various breakdowns of grades, and we use an f string to print out the actual grade. So let's try this. Save. We're going to say 500. Well, that's invalid, as we saw. So that worked. That executed this else statement. Let's say 50. You got a grade F because it's not greater than or equal to 60. What about 90? You got an A. And well, we could go on. 80 or 85. You got a B. And we could break this down into more granular grades if we so desired. But a very cool example of nested if statements, nested conditionals. And let's show one more example. And this is an example of checking if an item is in a list. So we have a list. The variable name is fruits. We're assigning that a value of, here we have our square brackets to denote the list. Apple, banana, and cherry. So it's a list with those three elements. And then we ask the user for their favorite fruit. So we ask for input, enter your favorite fruit. And that's assigned to the variable of favorite fruit. Now, if favorite fruit in fruits, what we're asking is this, if this value is in this list. And let's talk briefly about this in keyword. What that does is membership checking in Python. And it's a reserved keyword. We cannot use this for a variable name. Python understands it to mean we are membership checking. So if something is in or is a member of something else. For example, as we see here, a sequence of a list. It could also be a string. We could say if the letter A is in a string, we could membership check that as well. So if our favorite fruit that the user inputs into this variable is in fruits, print, yes, we do have that fruit. Otherwise, print, sorry, we don't have that fruit. So let's try that. Make sure I've saved this file. And we'll run it. My favorite fruit, let's say banana. Yes, we have that fruit. Let's try again with something that's not in the list. To pineapple. Sorry, we don't have that fruit. Let's check cherry. Yes, we have that fruit. And finally, mango. No, sorry, we don't have that fruit. So another great example of conditionals, and I hope these examples give you some ideas of what can be done with conditionals and some more help around how they are implemented. It's worth pointing out that we can also nest our conditionals. So just as we can nest our lists, we can have a list within a list, or our dictionaries, we can have a dictionary within a dictionary, or a list within a dictionary, or a dictionary within a list, etc. We can nest our conditionals. So similar concept to some things you learned before. I just wanted to point it out to you because it is worth being aware of explicitly. So how we do this is we can say if a condition is met, so if this condition 1 is true, And remember, every time we have our if statement or our else or elif, once we get to this colon, we can think of that, once we get to that colon, indent. Okay? So in most cases, when we see a colon, we indent. Not all. But at this point in the course, you can think of that as a helpful guide. So if condition 1 is true, colon, indent. And then we can have another nested if-else control structure. If condition 2 is true, well, this code will only be executed if both condition 1 and condition 2 are true. So we see if condition 1 is true, then we go down here, continue evaluating, condition 2 is true, yes, we'll execute that code. If condition 2 is false, we will execute our else code. So this code right here. So if condition 1 is true, condition 2 is false, we'll execute this else code. If condition 1 is false, what will happen? Well, none of this will even be looked at because condition 1 is false. So the program will continue running down here somewhere. So I just wanted you to be aware of that nested control structure functionality in Python and know that we can use it in this manner. All right, see you in the next lecture. We're going to now work on another exciting project, which is a personality test. So in this video, I'll show you what that's all about. And in the next lecture video, we will work on it. We're going to be creating a simple version of the Myers-Briggs personality test, otherwise known as the MBTI assessment. And if you head on over to themyersbriggs.com, there's a lot of useful information there, including a video about what Myers-Briggs type indicator or MBTI test is all about. And essentially, it's an assessment that we can take that a lot of people really feel is useful for understanding ourselves and understanding others. Understanding how we direct and receive energy, take in information, make decisions, and approach the outside world. So it can be an interesting test and help us understand a little bit about ourselves and others a little bit more. So this project will create a simple version of that test, certainly not as accurate as the actual MBTI test, but it can give us an idea, and you can show this to your friends and they can take the test as well. So as we see here, what this is all about is the test result will give you back 4 letters. 1 letter for each of these things here. So you're either going to get an E or an I, whether you're extroversion or introversion focused. You'll also get either an S or an N, a T or an F, a J or a P. So you'll get 4 letters once you take this test. And there are free versions of this test online that you can take. The most accurate one would certainly be from the Myers-Briggs website. I believe you need to pay money for that, though. But ours will just make for free. And I took this test, and I believe I'm an ISTJ. So that says I'm more focused on introversion, sensing, thinking, and judging. And we can see a little bit more about each one of those as we hover over those bits. So that's a little bit about the Myers-Briggs test or the MBTI test. We're going to be creating, as I said, a simple version of that. And just a fun little exercise using some of the things that we've learned so far in the course. So we will get to it and see you in the next video. Let's build our personality test. So first of all, I'm going to show you a run through of the program, and then we'll look at the program. So I have a file called personalitytest.py, and I'm going to run that with Python. And this is just some questions that are in the personality test. So I'll answer them to the best of my ability. I won't read through all them right now. So let's say when you're at a party, I interact with a few. I'm more realistic. Is it worse to? That's a tricky one. I'll say be in a rut. More impressed by principles. More drawn towards convincing. I prefer to work to deadlines. I tend to choose rather carefully. Okay, so I've answered those questions, and it outputs my Myers-Briggs personality type of ISTJ. So in the last lecture, I talked you through briefly what that means, so you can take a look back there if you're interested. But this is what our program does. It says I am an ISTJ, and I know I've taken this test before. Historically, the full-fledged test, which takes like a half hour or something like that, and I'm pretty sure I was an ISTJ on that. So this is somewhat accurate. Again, I don't think it's extremely accurate, but it's a fun program, and you can take it and have your friends take it, and something that can be interesting. It's a good way for us to test out some of the things we've learned in Python, such as input, user input. We're also looking at some if-else statements, which we've recently learned about. So we're putting those to good use here. So this is our personalitytest.py file, and this is attached as a resource to this lecture. So I'd invite you to find that attachment and copy the text onto your computer, and then you can run it, you can modify it, you can go through line by line and review it and make it your own. You can add questions to it to make it more accurate. So what I'm going to do is walk you through a little bit of the essence of this, and we'll talk about it. This personality test project. So first of all, we are printing out a welcome, and then we're initializing some variables. These are integers. So these are our Myers-Briggs characterizations. We're setting them all to the value of 0. And as we answer questions, which we see here's a question, here's a question, we just have various questions. We have 7 questions in our test, which again is not a lot. As we answer each question, depending on the input from the user, which we're setting to the value of an answer variable, we are adding or incrementing values of these variables. So if the answer or the input from our user for this particular question is 1, then we're saying add 1 to extroversion. That's what this plus equals means. We're saying extroversion is assigned extroversion plus 1. So extroversion equals extroversion plus 1. That plus equals is a common syntax that we'll see to do that. So if the answer from the user is not equal to 1, so we have our else statement, again practicing our if-else conditionals, then we'll say introversion plus equals 1, or introversion is equal to introversion, which was 0, plus 1. And so we have various questions. Each section here is just a question, and we're incrementing various characteristics depending on the question, as you can see. And then if we go down to the bottom, we are then aggregating that to determine the personality type. And I'll talk through that here in a second. But at the end, ultimately, of the program, we output your Myers-Briggs personality type is with an F string and our variable personality type. So personality type we're initializing right here to an empty string. And then we're saying if extroversion is greater than introversion, or if sensing is greater than intuition, thinking greater than feeling, judging greater than perceiving. Let me make that a little more uniform. We have these various if-else statements, and we're saying if-else, if this is greater than this, otherwise. So with each of these individually, we're adding a character to our empty string. So if extroversion is greater than introversion, then we add the character E. Otherwise, we add the character I to our string. And we'll just add sequentially 4 characters with our 4 if-else statements until ultimately we come up with our personality type, the Myers-Briggs personality type. So that is the guts of the program. Again, I invite you to download it and try it out and make it your own. And that will tell us roughly our personality type, which can be useful in helping us get along with others, helping us understand ourselves better, and helping us just live better lives. So a useful little Python program. These personality tests, you can find some for free online. Some of them cost money, but hey, you can make your own in Python. So I wanted to show you through, before we finish, just a little bit about what these values add up to. So I've got over here some text. I'm going to print the values of our characteristics here within our program. So just at the very bottom, before our if-else statements to aggregate the personality type, we're going to print the values of all these characteristics. So I'm saving that file. And let's come over here and run it again. And I'm just going to zoom through this, entering all ones. You see it says we're an ENTJ with all ones. And the values of our variables are as follows. So you can then do the logic and see, oh, if such and such a characteristic is greater than another characteristic, then we aggregate those strings. So you can see how that works is where we're looking at those values. And another neat thing with a neat tool to add to your toolkit with conditionals, if-else conditionals, we can also write them a different way. So I've got here what's called a conditional expression or a ternary operator. And essentially, this line, well, let me copy and paste this over here, and we'll show you the difference. I'm replacing all of this text, which is lines 99 through 117. I can replace that with these 4 lines right here. And what it does is it's result if true. So we're assigning all of this to a variable on each line, to this personality type variable. So this right here would represent everything from here over on each line. So we're saying result if true, so E, result if true, if, and then our condition, extroversion greater than introversion, else, and then the result if false, I. So either E or I will be assigned personality type. And that's just another way to leverage our if-else conditionals that I wanted you to be aware of, that can be useful if it makes sense in your code. So we'll continue to talk about things like this as we go along in the course. I wanted you to be aware of that. It doesn't always make sense to do this. I'm not saying you should do this all the time. I'm just saying if we have a bunch of if-else statements like this, and they're really similar, a simple way to condense that is by doing this conditional expression or ternary operator. is what it's called. Now let's just delete these almost 20 lines of code and replace them with our 4 lines of code. And we'll save. And let's run it again, make sure it works. And we'll just enter 2 for all of these this time. And we see it's outputted INFP for our personality type, but the program runs. So we've just consolidated that code. Interesting tidbit about those conditionals. And that completes our personality test. So again, I invite you to download that file that's attached to this lecture as a resource. Copy paste it onto your machine, test it out, see what personality type you are. Again, maybe not the most accurate. We only have 7 questions, but it's a fun exercise. I'd love to hear what personality type you are if you'd like to share. Okay, thanks guys. We'll see you in the next lecture. We're now going to spend some time learning about another conditional construct in Python called match case. And what this is it's very similar to if, elif, else statements in Python, so we can check for conditions. However, it's more simple and less powerful. This used to be switch case by way of note. However, starting in Python 3.10, that changed to match case. So it's had some somewhat recent updates to in Python to become match case. So if you're using Python 2 or an older version of Python, you will not have this available. You'll have switch case available. Now, some interesting things are that we cannot do expressions in match case, but we're just checking if values match. So think of an if, elif, else, how we could say if x is greater than 5, do something. Well, match case can't do that, but it can say match this value, and if the case is that this value equals this value, then process. And we will show some examples here shortly. We can also do the vertical bar within a case statement as an or operator. So I'll show you that as well. And the reason to use match case would be if you needed your code to be really fast. It's generally faster than if, elif, else. So if you can use it, you might as well. However, it's more limited. So I think you'll probably find most of the time you'll be using if, elif, else. And match case can only check if one value is equal to another. As I said, it cannot check less than, greater than, or other complex conditions. Now let's look at a side-by-side of match case versus if, elif, else. So here on the left, we have our traditional if, elif, else constructs. And we've got a variable called sides. We're assigning that to the value of 3. And then here we're saying if sides is equal to, and then a value, then set another variable called shape to some value. So we have various conditions here, as we can see, for various side lengths. And then we're saying ultimately, if it doesn't match any of those values that we've defined, then do this, process this else condition. And we'd print the shape. The equivalent to that with match case is, as you see over here on the right, we have these reserved keywords in Python, match and case. These are reserved keywords. So we can't assign them to variables. We're setting our sides to the value of 3, and we're matching on sides. So we're saying this is the variable that we want to check for equivalency. And then we're saying in the case that sides equals 3, do this. In the case that sides equals 4, do this, and so on. And then ultimately, we'll talk about this. Here we're saying otherwise, that's a wildcard. This underscore is a wildcard equivalent to else. Otherwise, if none of these cases match, then execute this code. So that is a straight up comparison of match case and if else to give you an idea of context of what we're working with here. And let's just look at a even higher level overview of match case syntax, where the expression is evaluated and compared to each pattern. And this overall syntax is similar to an if statement with, our colon, our indentation, and our conditions. So when we see this colon here, where we're matching on an expression or variable, and then we're saying colon, so we'll indent. If it's this case of pattern 1, let's say this expression is a value of 5. If pattern 1 is equal to 5, if we say 5 here for pattern 1, then this code will be executed. Otherwise, if it matches another pattern, it will execute this code. So very similar to an if, elif, else construct in Python with a few differences. However, I think you'll get the hang of it pretty quickly as we continue talking about this match case syntax. Continuing on with our match case discussion, let's talk about some things that we can match on, some ways that we would match here with our cases. So with literal patterns, we can match a simple value. So let's say we have a variable x assigned to the value of 10. We match on x. We're saying, okay, in what case, let's compare our cases to x. So in the case that x is 10, we'll execute this code. In the case that x is 20, we'll execute this code. So pretty straightforward. Let's move on to matching sequence patterns like lists or strings. We can have a variable colors assigned the value of a list that contains red and green. The strings red and green. So we're matching on that variable colors. And in the case that variable is a list with red and blue, we'll print red and blue. In the case that it's a list with red and green, we'll print red and green. And one note, if what were to happen if this colors variable were assigned green, red, so the inverse order, it would not match any of these. It is order sensitive. Order does matter. So that's a little overview on matching things like lists in these sequence patterns. Now, here's a really interesting slide that I wanted to share with you that can add some power to our match case conditionals. We have a wildcard, this underscore that we can use that matches any value and can ignore it if we're using it in this type of situation. And then we can also bind values to a variable from our variable. So let's say we have point and it's assigned of a tuple. The tuple contains 2 and 3 in this tuple. So here with this binding, we can say, I want to grab this variable, whatever it is, I'm going to grab it. And so it's an automatic match on this variable. It doesn't matter what this value is. It's just going to grab it. And it will print out an f string saying x is, and then print out the value of x here. So it will be x is 2. And here we're using a wildcard, so it also doesn't matter what this variable is, or what this value is, rather. We're just saying, I don't care. So we're matching point. We're matching here because we're just grabbing a variable. We don't care about the match, and we're using a wildcard saying, again, we don't care about the second value in this tuple. So if we remove this wildcard and put in, let's say, the number 2, it would not match because it would be looking for a match here of 3. If we removed this x and put in the value 2, that part of the tuple would match. And if we left our wildcard here, then this condition would match and it would print. So a little bit of more useful handy tools there with our match case using wildcards and binding. Now, lastly, before we get on to some examples, let's talk a little bit more about this wildcard and how it can actually be used as a catch-all to catch all unmatched patterns, or in other words, like an else statement. So if elif else, that underscore, if that's our last one here, our last case, it will just match anything. So here and it works like default in traditional switch statements, the default case. So anything that's not explicitly matched. So we can have a value variable assigned to the string hello, or matching on value. So if this value variable matches hi, we'll print saying hi. Otherwise, print something saying something else. So this here will match this catch-all wildcard pattern. So that's something that we can have equivalent to our else statements in our if, elif, else conditionals. It can be useful. Let's take a look at 3 examples of match case scenarios to further solidify how we can use these. So first of all, we're going to take a look at some binding and wildcard. So we did talk through this a little bit in the lecture, but I wanted to highlight it again. We have a variable called point, and it's assigned a tuple, which contains the values 2 and 3. Let me make that a little bit bigger for you. So if we're matching that variable, we have x, we're binding that x right there. In other words, we're capturing it and we can then print it out. And here we have a wildcard, so we don't care what matches here. So we are going to match this case and we will print out the value of x. So let me save that file and run that script, and we see we do indeed print out x is 2. Now what if I were to put the number 5 here? So our case would be simply bind this variable, we don't care about a match, and then we match on the 5. So are we going to match? Let's save it. Run it again. We do not match because we're not printing anything out here. So let's put that to 3. Save it. Run it. We do match because we don't care about this x. We're just binding. And then we do match the second value of the tuple, which is 3. So we do print out x. The value of x is 2. So that's our first example. Let's delete that and look at another example. And here I want to highlight for you, I'm not going to cut that. Let's just copy here. I'm going to highlight for you using our bars as ORs, logical OR. So can match this or this or this or this or this. So we have a variable called char, a character. We're setting it to the value of a. We're matching on that variable. So if any of our cases match a, we'll execute the code for those cases. So what do you think will happen? We have a case that matches a or e or I or o or u. We have a case called y. We have a case of wildcard. Well, let's save it, clear, and run it again. Run our script. A is a val because we match on this first case. Well, if we were to change the car or char variable to just some gibberish, let's save and run it again. We're saying it's a consonant, and now that's kind of misleading. So we need to be careful when we're matching like this, because all we're saying is every other condition. It's like an else statement in our if, elif, else. And we're saying it's a consonant. So we need to be sure we know what our parameters are. So let's just change this to f and run it again. Now f is a constant, and that is actually accurate. So we're expecting this to be a single character. So now we can change it to y, and we'll match the condition that we have not matched yet. Sometimes y is considered a val, so we printed this condition under the case y. Okay, so that's our second example. I wanted to show you these logical ORs again. Well, you know what? Let's put in another value from here, from this case, just to make sure we're demonstrating that fully. So let's put in the value u and run it again. And see, it does indeed match. U is a val. It does indeed match this top case. So let's go on to our last example. This one I just want to show you a little bit more of a in-depth example. And this one is a very, I think, great use case because we're using response codes, HTTP response codes. So you could certainly see yourself, I think, using a match case like this, depending on what the response is, because they're always going to be a set of responses for HTTP status codes. So here we have a dictionary. Its name, the variable name is response, and we see open curly bracket, close curly bracket, representing our dictionary, beginning and end. Then we have a key called status and a key called message, with values of 404 for the status and not found for the message. So we're just pretending we got an HTTP response, and this is what we got back. So let's now check our response, the value of status. So the status code, which will be this 404. That's an integer in this case. So we're matching and checking against all these integers, different cases, and printing different things based on the response. So let's save that and see what occurs. We see error 404 not found. That indeed matches this case here. Error, then we're printing out the value of response status, which is 404, and then we're printing out the value of response message, which is not found. If we change our response to, let's try 203, let's see what happens. Unhandled HTTP status code. We're saying our code does not handle it. So we're getting the catch-all there. And if we try one more, we can just say 200. I will change this message. Success. Let's just say success. And let's run it again. Success. So we matched on that 200. Our response matched this case. So there's several examples. I hope that shows you a little bit more. It helps solidify for you how we can use match case and how it can add value to our Python programming. All right, see you in the next lecture. We're going to take a step back now from learning Python, and we're going to now focus on learning the Python IDE PyCharm. It's an application, an integrated development environment. That's what that stands for. It's an application that helps us code more efficiently and with more powerful tools at our disposal. I'm on a Windows machine right now. I know that a lot of you are learning on Windows, and so I may continue to switch back and forth here and there between a Mac and a PC, but I'm going to download this on a Windows computer and walk you through it. And you'll see that I'm over here on jetbrains.com/PyCharm. If you just search in Google or another search engine for PyCharm, you will find PyCharm. And we're going to download it and show you what it's all about. So here we have a download button. Let's click that. And we're going to install the free version So let's go over here to other versions. We want Community Edition. And I am on a Windows machine. So we'll speed through the download here. Let's accept. And now, as we set up PyCharm, we'll just click next through the installer. We'll locate a space for this. I'll just put it under Program Files. Next. Next. Install. All right, once that download isn't finished, once that install is finished, then let's run PyCharm and click Finish. Accept the terms and conditions. I click Don't Send. Okay, so here we are in PyCharm. And in the next few videos, we will get familiar with this application and how we can write code in it and use a lot of the tools it has to offer. Now that we have PyCharm opened up, let's explore the UI a little bit and get familiar with it. So first of all, what we're going to do is create a new project. And this is just what PyCharm uses and views with your structure of your code. So we could have a project dedicated to certain purposes. We might have a project for writing project A, and we'll have a different project for project B. We could also just open up Python files in here and edit them. But what we're going to do is open a new project. By the way, if you'd like to take a tour, you could start a tour of PyCharm, get a little bit more familiar with it that way as well. I'm going to click New Project. And what we see here, we can give it a name. So let's just name this Test PyCharm. And we can create a location for that. We're going to just use the default here. It will create a PyCharm projects folder and put our test PyCharm folder in there. Our interpreter type, this will create a virtual environment, which we'll get more familiar with later in the course, but it detects that I already have Python installed. So it's going to use that in PyCharm's virtual environment. In other words, PyCharm will interact with the Python version we have installed and use that to run our code. So let's click Create. And it's creating that virtual environment. It's creating that local Python environment with the version that we have installed on our system. So here we now have a folder hierarchy, our test PyCharm folder that we just created, some other folders that we don't need to pay any attention to for now. But under this main folder, we can create our code. So we'll do that here in a minute. But I wanted to show you what's here. Well, let's actually create a new file. So I right-clicked on this folder, as you see, and I'm saying New Python file. Let's give it a name. That'll be test.py. Okay, so this main area is where we write our code. See, I'm just writing Python code here. And if we look down here, we've got some toolbars. The one I want you to get familiar with for now is the terminal. So I'm going to click that to open it up. And this is a space down here that is similar to if we had a terminal open, where we can type Python and then the name of our file, and it will run our code. We've been doing a lot of that in the course up to this point. So this will come in handy and we can interact with our code in this way. The user inputs would be in this terminal, for example. So if I say print hello, and then I want to say input equals input, enter some text, please. Then let's go up here to the right. We see selected is our current file. Sometimes you have to be sure that's selected, or it will run another file that you're not intending. We've selected the current file, this test.py, and we can click this play button to actually run it. That will run our code. So if I click play, we see down here in this terminal now, enter some text please, and it printed hello. So the terminal is a way to view our output and enter inputs as a user. Okay, so then our code finished running. Another area which we have kind of highlighted is just this folder hierarchy. That's our project. So if we ever end up clicking on another thing, we can come back to this folder icon and find our project right there. And find our files and click on our file, test.py, to edit it, for example. So in a nutshell, that's what I'd like you to get, get familiar with for now, for this video, where we write code, where we can look at the file structure that we're in, and our terminal, which is where we can execute code or view things. So if I'm here, I could type Python and test.py, and it runs our code like that in the terminal. Hello. So I misspoke a little bit earlier. When we actually hit our run button, that actually goes to this run space. So either from the terminal we could run our text, or from this run space. I recommend most of the time clicking these buttons up here. It's just easier to interact with. Then if we click stopped, we'll terminate our program and it finishes. So again, that's just a brief overview of some of the spaces in PyCharm and how we can actually start writing code. Let's look at debugging in PyCharm. So we've got some code written, and let's say we want to see what's actually going on. And this is one of the very powerful things about writing our Python code within an IDE, within this integrated development environment, which in this case is PyCharm for us. We can use these debugging tools that make it easier to inspect our code as it's being run and see values of variables, see where errors might occur, things like that as the program is running. So in order to debug, what we can do is, instead of clicking this play button to run our test.py file, we can click this debug, and that will debug our test.py file. So let's see what that looks like without making any other changes initially. And we see down here in the left, we have our program running. So let's stop that. And let's modify our code a little bit, make it a little easier to view this debugging. Let's just create some variables. And then print, let's just say var2 plus var3. So let's now hover over one of these lines that are displayed to the left of our code, and you see there's a red dot that appears for every line of code we have. And this is where we can make a breakpoint, which is something that when we debug, we can tell the program to stop there. and wait there while we look around. So I'm going to create a breakpoint here by clicking. Now you see there's that red dot, and I'm going to hit the debug again. So now our program has stopped here. It's mid-run, and we can look under this debug section at some of the values of our variables. So we see var1 is equal to high, var2 is equal to 5, and that can be very useful. If we're running a program and we need to look at things, figure out what's occurring, we could have dozens or hundreds of variables here and inspect them. So very useful, very powerful in PyCharm. Now, if we want to keep going, what we can do is down here in our debug pane, we see there's a few buttons. We can resume program, which will just continue running the program through the end. Or we can step over. We can step into, step out. So right now I'm just going to talk about continuing and step over. We'll get more into these details in a future lecture when we get into another IDE that we're going to be using more, which is VS Code. But if we just hit resume program, it just continues on and finishes the program. Let's click debug again. And what we can do is just step over. We see it just goes to the next line. So we've added a variable here to our output. So we can view the variable var3, and that's value is 100. So we just preceded a line of Python code. And that step over is very useful for just going line by line and looking at values as they change. So that's a little bit about debugging in PyCharm. And we'll use this for a little bit and build on this foundation as we use it. And I hope you can download it and start testing your own Python code. We are getting more and more interesting as we progress through our Python journey, now beginning to learn about loops. And we'll be talking about while loops here. So, first of all, let's figure out what a while loop does. A while loop is a control structure, just like our if-else conditionals and control structures, that repeats a block of code as long as the specified condition is true. So it's useful for scenarios where we don't know the number of iterations in advance, or if we have some sort of counter we're trying to iterate through. For example, we've got a real-world scenario here where while our phone battery is less than 100%, continue charging. And there's lots of other examples where a while loop makes practical sense for us. So let's learn a little bit more about them. The anatomy of a while loop is that this loop will continue executing as long as the condition remains true. So if we look here, we have this keyword, this Python reserved keyword, while. You can only use that for a while loop. That's what Python interprets that word to mean. So we say while, and then we follow that with a condition, some code, an expression that evaluates to either true or false, and then a colon, and then indented below our while loop, one indentation level, one tab or 4 spaces normally, we have our code to run while the condition is true. If the condition becomes not true during this execution, Python will exit the while loop and continue on sequentially down the code. Now, as long as the condition is true, it will never stop executing the while loop. For example, over here we have a snippet, while true, print hello, and the output will just continue on forever. So you have to terminate that program with something like Control-C, or it will just keep going. By the way, I'm on my PC because, as I mentioned before, I want to show some PC, some Mac tutorial here, just to mix it up. And I know a lot of you are learning on Windows as well. So I don't have my nifty screen brush tool to highlight the text. I may update that later on and make a new lecture video for some of these Windows ones. But for now, I do apologize. It may make it a little bit more challenging to follow along. So I hope you can follow along with the mouse here. So that's a little bit about the anatomy of a while loop. And we will continue learning more in the next video. Just like our if-else conditionals, with while loops, we can use operators such as or and. We can also use not, and we can use these to specify the conditions which need to be evaluated to either true or false in order for our while loop to execute or not execute, or execute some, and then if the condition becomes false during the execution, during these iterations, then to cease executing. So we can use multiple conditions for a single statement, as we see here, just trying to make it real world example. While phone battery is less than 100 and power equals true, so let's say we have power at the electrical outlet, then action is assigned continue charging, or we could say variable name continue charging equals true, or something along those lines. And we could even call a function here. That would probably be more appropriate, but we haven't learned functions yet. But we would just execute this continuously until phone battery became 100. So it was not less than 100, or if the power became false. Remember, with our AND statements, both of these conditions need to be true for the entire expression to evaluate to true for the while loop to execute. We could also say while battery is less than 100 and not power equals false. That would have the same effect. Just a note, I wanted to point out that we can use these or and operators in our while loop. And again, always remember your colon after the line with the while reserved keyword. So while expression that evaluates to true or false, colon, and we've got our indentation, and anything we want to run inside the while loop will be indented, at least this one level, for Python to recognize that it's part of the while loop. So that's a little bit about our operators that we can use in while loops. The question arises, as I briefly mentioned earlier, of how do we break out of a while loop if it executes while the condition is true, and it just always executes if that condition is true? What if we have mistakenly programmed something where our condition after this while statement is always true? Well, one way that we can ensure that our while loop exits and doesn't just continually run, we can ensure that our while loop exits and continues processing the code below it that continues in our Python program. We can use what's called a control variable. And a control variable is what the loop condition can check here after our while keyword to determine whether to continue. Not updating the control variable can result in an infinite loop in which we'll have to control C if we're running that in our terminal. I'll show you some examples of that. So count in this instance is our control variable. And so what we're doing is we're setting that to 0. We're saying while count is less than 5, colon, indent, print count. And then we're incrementing our control variable by 1. Count is equal to count plus 1. again, this plus equals, this increment operator is what it's called, just says assign count to its own value plus 1. Whatever is to the left of this plus equals, assign its value to its own value plus whatever is to the right of the plus equals. So count equals count plus equal 1. So as you can see, we'll iterate once. Count will then increment to 1. We'll iterate this while loop again. Count will increment to 2. We'll continue on. Count will increment to 4. It's still less than 5, so this condition is still true. We'll print count, we'll print 4. We'll increment to 5. We'll come back here to the while loop. Now count is equal to 5. It's not less than 5, it's equal to 5. So we will cease executing any code within the while loop, and we will continue down executing code after the while loop. So let's hop over to our PyCharm editor and take a look at this. And again, we're going to get familiar with PyCharm first of all, and then we'll get familiar with another IDE, VS Code. And I think these are both great editors to have in your toolkit. So I'd like you to introduce you to both of them, but starting with PyCharm. So let's, we opened up PyCharm, and let's open up a new project. So file, new project. We're going to name it while loops, and it will just go in this default location under the folder PyCharm projects, using Python 3.12, which is our default. We could select a different version if we'd like, but our virtual environment is just going to use Python 3.12. Again, we'll get more into that virtual environment later in the course, so you don't need to worry too much about that. So I know where my project is being created under this folder. I know the name of the project, so I'm going to create it. And I'm going to open this project in this same window. I don't need a new PyCharm window. So we're now creating our project. There we go. So we have a folder called while loops. As we see, it's in this directory. On the folder is while loops. And I'm going to right click on while loops, this folder. I'm going to say new Python file. And let's do loop control variables. So we see we've created loop control variables.py under that while loops folder. I want to show you something here, just as a side note, because I know we haven't done too much in Windows yet. But if I navigate cd, change directory, to this directory, so C, so I'm already in C, users, Joseph. I need to go to PyCharm projects, while loops. So Python, I'll just tab to autocomplete. And while loops, I'll just tab to autocomplete. So now if we do dir, I see the files in this folder, and we see our loop control variables.py. Let's add a little bit of text to that. Let's just say print, you are here. And I'm going to save. Okay. Whoops, I'm just going to do Control S. That's the easy way. And so I've saved that file. Now if we just run Python loop control variables, you are here. So I just wanted to demonstrate, these are just different ways of running our program. We can also, so we can run it at the terminal or the command prompt like we've just done there. We could also run it here. We have our current file selected. So this loop control variables, this is the current file that I have open. If we had another file, and I'm just trying to teach you as we go about PyCharm a little bit, and then I ran this, it would run another file. So let's Control S to save and run. Here we open up our run docket, and it says another file. We printed out another file. But if we click on loop control variables and click run, you are here. So just to highlight that, by default, it's just going to run our current file. So where were we? We were talking about while loops and control variables. Let's test that out. I think I should probably make this a little bit bigger. Let's see here. Where's our zoom? Oh, here we go. Increase font size. Alt, Shift, period. Alt, Shift, period. There we go. This should be a little bit easier for you guys to read. So let's change this. Let's create a control variable. I'll just say control variable equals 0. And we're going to create a while loop. While control variable. And this is one of the benefits of IDEs, by the way, specifically PyCharm in this instance, but most IDEs will have some sort of autocomplete. So I could just hit tab and it completes that based on the variable that it already knew that I had defined. While control variable is less than 5, enter. PyCharm will automatically indent for us. Let's print. Let's use an F string here. Control variable is control variable. That's our variable. And then we'll unindent. So this will not execute in the while loop. This will execute after the while loop is done. We're just going to print done. Control S to save. Now let's run this and see what occurs. What have we done wrong? We're missing something, aren't we? As you can see, this is an infinite loop. I wanted to demonstrate that for you. It is just continuously printing. So let's stop that. That is a lot of output. As you can see, it runs as fast as your processor will handle it, and it's truncating a lot of output too. So if you can think, what are we missing here? Well, control variable is 0. While control variable is less than 5, do this. Okay. So it does this. It goes back to the top of the loop. Is control variable still less than 5? Yeah, it's still 0. So it will just execute indefinitely. What we are missing, as you probably noticed, is we need to increment our control variable. So control variable plus equals 1. Let's try that. There we go. So if we look here in our run pane, we ran the program and it's printing out control variables 0, 1, 2, 3, 4. And then it prints done. It exits the while loop and goes to done. So lastly, what I want to do in this video, I know it's becoming kind of a longer video, but this is a very key point. I want to do some debugging and step you through this while loop. So if you recall from our PyCharm debugging video, what we can do is we can hover over one of these numbers where we have some Python code in that line, and this red dot will appear. We'll click it. We're going to make this a little bigger. So that becomes a breakpoint in our code. Then we can come up here and hit debug, and it will stop our program at that point. So I've hit debug, and we can look at our variables. So we see control variable down here is 0. That's the value. So let's step over. Okay, so control variable 0. It's entered the while loop now, and it's printed control variable is. So if we look at our output here in the console, see control variable is 0. This is our debug console. just like our terminal. Now, if we go back to view these variables, let's continue on. So here we're on this line, so it's incrementing control variable now. Now control variable is 1. We're back to the top of our while loop. Let's continue on. So it goes into the while loop again because our control variable is still less than 5. Let's step over that. In our console, we see it now printed control variable is 1 from this line. And I'm going to proceed on, stepping over. We are executing the while loop. We're stuck in this while loop intentionally because our variable is still less than 5. Variable is now 4. Now our control variable, this integer is 5. And we see that we've printed out all the way up to 4. So now, while control variable is less than 5, this expression evaluates to false. So where is our program going to go? What line will it go to? Well, if we hit step over to continue, it does not execute the while loop anymore. It knows this this expression is false, so it goes outside the while loop, outside this indentation level, to the next non-indented line with equal indentation to the while loop. And we're now here. And if we hit next, we printed done. So I wanted to show you that IDEs are super powerful with debugging and going over our code line by line. And I wanted to highlight for you how a while loop executes and how it keeps looping through while the following expression is true. Sometimes we want to be more deterministic in when we exit a while loop. Or we want to say specifically, get me out of the loop right now. And that's what the break keyword accomplishes. So within a while loop, if we have our break keyword, what will happen is it will immediately exit the while loop regardless of the loop's condition. So this could be true, while true. So that's always true. The expression here is always true. It's always going to execute, but when we see break, we're done. We exit the while loop and we come down to the next line of code, non-indented or indented at the same level as the first character here of the while loop, down farther in our program, right? So we'll be done executing whatever's indented here under the while loop and we'll continue on in the program. So that's what the break keyword does. It's an important component of learning while loops. So let's take a look at that. We've got PyCharm here. And let's change this a bit. We don't need our control variable anymore from the previous video. So another thing I love about PyCharm, by the way, it's a great teacher for PEP 8 standards. And I was reminded of that by this highlight here. This is actually an error, because it shows me, hey, I don't have a variable named control variable because I deleted that. But one thing also that we can see, I have to scroll way over here. You see this line on the very far right? That's 79 characters, which is a PEP 8 guideline that each line should not be longer than 79 characters. So that is there's a lot of very useful little tidbits in PyCharm that help us to get better at programming according to standards and convention. Another example is, well, let's just say while we're on the topic, I can show you some things. So var1, var2 equals blah. Check this out. So it's highlighted this for me. It says too many blank lines according to PEP 8. And let's see, let me highlight that again. Show quick fixes. Well, reformat. Okay, it didn't actually explain the fix there, but it wants one space in between kind of unrelated pieces of code. or 0 spaces, which is fine. But if we have lots of spaces, then PEP8 doesn't like that. Anyway, my point being, PyCharm will help us learn programming in Python very well because it closely aligns with PEP8 standards and can give us hints. So I encourage you to pay attention to that. And that's one reason why we're learning PyCharm as an IDE first, so that you can use that and get familiar with some of the helpful things that it gives us. So where were we? We were creating a while loop, and we were just going to show the exiting the loop intentionally, or exiting the loop very deterministically with our break statements. So we got so far while true. Let's use input. We've learned about input. Whoops. Learned about input. And say enter key Q to quit. Okay, so input. And then we're going to say if, let's assign that to a variable. User input is assigned input. It's assigned the result of this input method, enter key Q to quit, which will be a string. So user input will be a string. If user input equals Q, the letter Q. We could also do something like if user input dot lower dot, and look here, oh man, so many cool functions with PyCharm. I love PyCharm. It will show us the available methods on strings. So we could do something like lower, and we'll see, we can just select that. It makes whatever user input is a lower case string. So we always know that if they enter Q, whether it's uppercase or lowercase, it will equal lowercase q, what I have defined here, because we use that. We translate it to a lowercase. So if user input dot lower equals q, break, then we'll stop executing immediately. And we'll just print down here, print done, just so we can see that. So let's execute. And here we are in our run pane, enter key, Q to quit. Well, what I should have done here, I'm going to stop this execution just for readability. I'm going to put a colon and a space. It's a little bit easier to read where I need to input. There we go, that looks better. So let's put hi, blah, A, B, C, D, 1, 2, 3. See, it's just taking inputs. And until I press Q, it will keep iterating over this while loop. Everything in this loop, it will iterate again and again and again and again, because our condition is always true. But if our user input is Q, exit the while loop. So I have now inputted Q, and I'll hit enter. And we then exit the while loop, and we print done. Just to demonstrate the lower method, again, we could also enter uppercase Q, and we're done, because we translate that to a lowercase value. So some more useful things about PyCharm, as well as learning about breaking out of while loops intentionally with the break keyword. We've talked about breaking out of a while loop. Let's now talk about skipping any remaining code in the while loop and going back up to the top. So in other words, we've got a while loop here, an example, and we're iterating through, repeating this loop while the count is less than 5. And we want to print the count. We see all this is indented in our while loop. It's all part of the while loop. Python sees that. We want to print the count, but with one exception. If the count is equal to 3, we don't want to print the count. We want to continue to the next iteration of the loop back at the top here. So what we can use is a keyword called continue, and that continues with the next iteration, skipping everything within the while loop that is below our continue statement. So the continue statement proceeds to the next iteration. So let's take a look at that. So let's create a while loop as we've demonstrated. Set the count variable to 0 while the count is less than 5, colon, indent. Count is assigned count plus 1. If, however, count equals 3, continue. So skip everything down here. Print count. So this print is always going to occur except when this continue happens within our while loop. So let's try this out. What do we see? We see we've printed out 1, 2, 4, and 5 because we've skipped. So let's debug this to show more in depth. Whoops, I need to set a breakpoint, otherwise we're not debugging anything. Let's set our breakpoint at the beginning of our while loop. Debug. And let's just step over a few times because we know count is not equal to 3. Look here how in PyCharm it shows the value of our variable to the right. That's also very handy. We can see how IDEs just help make our programming journey and programming life a little bit easier. So now here we are. If count equals 3, well, count is 2. So we're not going to enter our if conditional. We're going to skip it. So hit next, step over. You see we skipped it. We just went to print. So we're going to print count again. Back up to the top of our loop. And count is still less than 5. We're incrementing. And you see here it's just a little formatted a little bit differently. We're having our count variable at the top. So just a little bit different approach. We could have also just started with count 1 if we wanted to and put count down at the bottom. Just a different way of doing it. So if count is equal to 3, count is equal to 3. Count is equal to 3. So what do? We're entering our if statement. We see this blue line. We are now on this continue statement. So what's going to happen? Are we going to print count? We are not. We're going to hit this continue. We're going to go right back up to the top of the while loop, as we just did. So that's a demonstration of what the continue statement does. Sometimes we need to do that where we don't want to execute some of the code. We want to just move on to the next iteration. And that's the continue in our while loops. Before we get into our guess the number game project, we need to talk about the random module. And this is a module in Python that generates random values. It has various other functions, which we won't get into at this juncture in the course. But it's very useful for generating random values and will help us with our project. So what it is, it's a built-in module. We haven't talked too much about these yet. So we need to import this module into our Python program. It's built into Python. So when we download Python, it comes with this random module. Think of it like extra code that Python can use, but it's not generated into our program by default. So it's not loaded into that memory. We need to specifically import random right here, import random at the top of our file in order for our Python code, our script, to include all that code that comes with the random module. It just helps Python be a bit more lean, and we only need to import what we're actually using. We're not going to import everything that Python has to offer. So random will give us those random values, and don't forget dir and help. Let me show you an example of that. But first, I've got a screenshot here. So we need to import. This is a keyword in Python. At the top of our script, import, and then random is the name of the module. Python knows what this random module is. It knows where to find it. It's in its code, and it just brings that into our program at runtime so we can use the methods contained within random. So here's an example. We have secret number equals random. That's our module. And we've got a dot here to specify a certain method from the random module that we're going to run, that we're going to call, which is randint. You can probably guess what that's for, generating a random integer. We put two parameters into this method, 1 and 100 in this case, and it specifies the range that will be returned from our random value. So let's take a look at dir and help real quick, and we'll come back to our slides. So I've got PyCharm up here, and wanted to show you, I don't believe we've discussed this yet, all these panes here on the left. We've looked through them a little bit. We have talked about the terminal, haven't we? So I'm in the terminal right now. So I'm just going to show you some real-time things with random. So what we're going to do in the terminal, Python, and this is just like the terminal on your computer, on your PC, or command prompt on your PC, or a terminal on your Mac. So what we're going to do is import random, and let's do dir random. So I want to just show you some of the methods here. Some that we'll look at include choice, shuffle. Let's see, there are a few here. Randint, generate a random integer, and randager, generate a random float. So if we do help on random dot, let's say randint, we see return random integer in range A, B, where A is the first parameter, B is the second parameter. Remember, those are separated by a comma, each parameter, including both endpoints. So it can return A and it can return B. If A were 1, it could return 1. If B were 2, it could return 2. Now just a few methods. Our randint, we've talked about, return a random integer between A and B. Random.random, return a random float between 0.0 and 1.0, excuse me. Random.choice, and then as the parameter, we insert a sequence, like a list or a string, something that can be iterated over. And it will randomly select an element from that sequence, for example, a list item or a character in a string. Then we have random.shuffle, also inserting a sequence, and it shuffles the elements of the list in place. So over here on the right, I have an example of random.shuffle. We have a list called fruits with apple, cherry, and banana. And we call random.shuffle on our list as the parameter. Then we print our list again, and we see it has reordered the list to be banana, cherry, apple, as opposed to apple, cherry, banana. If we call random.shuffle again on our list and print it, we see apple, cherry, banana. And that actually just reverted it back to the original list. There's only 3 items, so that's bound to happen. This is like shuffling cards. So you could envision a Python program where you have 52 cards in a list. Just for simplicity for our discussion here, you could envision that, and we could shuffle our cards. So lots of uses for that method. And then over here on the left, we import random at the top of our script. This code snippet on the right is a continuation of this script on the left. So we've already imported random here. If we don't import random, it will fail. I'll actually show you an example of that. But we call random.randint 1, 10. So it will return an integer between 1 and 10 inclusive. It returns 8. Random.random returns a float, lots of digits here, between 0 and 1. And then we create another list, my list, and random.choice, inputting our list, returns 1 element from that list. So let's go back to PyCharm for a moment, and I want to open up a new terminal. So I'm terminating this terminal. I'm going to open up a new one. Python. What if I try to run random.randint? See, name error. Random is not defined because Python did not load up random, the module, from its libraries. It did not load that up on runtime. So did you forget to import random? Why, yes. Yes, I did. So then if we import random, random.randint, missing. Oh, I was thinking to myself, why did it fail? It's because we need our arguments in there. And we see it works now. So just we need to include that random.randint. So now that we're familiar with random, that's a great module to be aware of. You'll use it certainly in many Python applications. But now we can continue on with our project. I have a fun project, what I think is a fun project for you guys, and a useful one. And it's going to be Guess the Number, a little game that you can play, show your friends, and demonstrates a few of the key principles that we've been learning about, most namely while loops. So what we're going to do is, for this Guess the Number project, we'll initialize a random number. We've just learned about random numbers. We'll take input from a user, which we've done previously, for their guess. So they'll enter their guess of which number we're trying to get them to guess. We'll then determine if the user guess matches the random number or not, and provide feedback. Your number was too high, too low, that was the correct guess, etc. When they get the correct guess, we will exit our while loop. So let's go over here to PyCharm, and I've got our program open from previously. Let's create a new project. And we don't need to create a new project necessarily for everything that we do. We could have, for example, a project and just have a bunch of Python files underneath. I may do that here for certain things, but we are going to, for now, just to get you more familiar with creating projects in PyCharm, we'll create a new one, and we'll name it Guess the Number, and create. We'll create it in this window. I don't need, well, let me show you what would happen if we did new window. So see, it just creates a new window. So now what I'm going to do is close out the old window. But what I could have done was create in this window, and then it would have just replaced it. So I've got a new window here. Let's right-click on our project, create a new Python file with the name Guess the Number. So I've got our steps copied. Let me paste those in. Okay, that's what we need to do. So we'll call this step 1, step 2, step 3, and step 4. So for step 1, let's initialize our random number. Remember, we always need to import random. So as long as this comes before our other code where we reference random, that's okay. Best practice is to have it at the very tippy top of our file. I'm going to put it there above our comment here. And actually, that brings me to a good question. Is this okay to go here? Let's see, what do we got? We need our parameters again. 1, 5. Let's run our current file. Well, we're not doing anything. Yeah, that works. So it didn't throw an error. Just want to make sure I wasn't misspeaking. I've always put it at the top, and with the assumption that it could be anywhere in our code as long as it's above what's referenced, and that proved to be true. Below our comment worked just fine. So what we're doing is let's initialize a random number. Let's say random number is assigned the value of random.randint. We'll go between 1 and 50 for now. And then so that's done. Step 1 is done. Let's take input from the user for their guess. And we need to do this in our while loop, because every time they guess, we're going to give them another chance to guess until they get it right. So we need to repeat some block of code an undefined or indeterminate number of times while they guess. So while. Now, what is our condition going to be here? What can we say while what? Keep repeating the loop. Well, while the guess is incorrect. So what we can do is we can create a variable, which we could use as correct guess, and we're going to assign that to the value of false. Or we could do incorrect guess and assign it to true. Let's do that. That makes a little more sense to my brain. So incorrect guess, we're going to just assume that's true. And then we say while incorrect guess, which is true right now. So this will iterate at least once. And we're going to say user guess equals input, enter guess. This will prompt the user for their input. And what I'm going to do is translate this to an integer. So we're going to use that int method we've learned about. Okay. Now, that takes care of step 2. We've taken input from the user for their guess. So we're still in our while loop. So this will iterate once. Let's check to see if they are correct. So if user guess equals random number, then let's print correct. Okay, and then let's break out of our loop because they've guessed correctly, so we don't need to run it anymore. Elif user guess let's say is less than random number, print too low, try again. And finally, the only other scenario here is if their user guess is greater than our random number. So we're just going to print too high because that's the only other scenario that remains. Try again. Okay. And let's see if this runs. Run our current file. Enter guess. Let's say 5. Too low, try again. 6. Too low, try again. 7. Too low, try again. 8. Too low, try again. 9. Too low, try again. Okay. I forgot this was between 1 and 50. I thought this was between 1 and 10, so I was incrementing by 1. Let's go a little bit higher. 30. Too low still. 40. Again, too low. 45. Wow, that was a good guess. It only took me like 8 guesses, but I eventually got it. So correct, and we finished our code. We hit this breakpoint, excuse me. Let's try again. Let's say 25, too high. Okay, 15, too high. 10, 5, too low. 7. Okay, so it was 7. So a pretty simple program. What if we wanted to add how many guesses it takes us? So we could add a counter here, and we could say num guesses, or maybe attempts. I like that. We'll say 0 attempts, but every time they have a guess, let's increment that. Attempts plus equals attempts plus 1. So we're incrementing that. And we can say, we can make, let's see, if user guess is equal to the random number, let's make it an F string. Correct. You guessed the number in attempts. So let's run it. Okay, 25. Oh, wow. It was 25. Yeah, that's got to be some sort of record. Let's try again. Well, it worked because I guessed it in 1 attempt, but let's try again where we got a few more attempts. I'm just starting in the middle because that's logical. 15, too high. 10, too low. 12, 13. Okay, 5 attempts. 1, 2, 3, 4, 5. You guessed it in 5 attempts. So, pretty nifty random number generator / guess the number. We did that in 25 lines of code. Actually, if we take away all of our description here, 20 lines of code. You can start to see how, with the correct logic applied together, we can make some pretty decent programs. So I hope that was interesting to you, and you can see some use cases for our while loop. User input's a great use case for while loops, getting user input until conditions are met. We used our random number generator, importing random. We've got our if, elif, else. We use a break statement, f string. So lots of little things starting to come together to make more comprehensive programs. I wanted to make a quick note here before moving on that we don't actually use this incorrect guess variable to terminate the loop. It's just always true, which does work and is fine, and we have our break to terminate the loop. I wanted to show you another way of doing this. Instead of break, we could just change incorrect guess to false. And that way, once this code executes, if we have the correct guess, this will now be false, and it will stop termination. It will terminate the while loop. It will stop iterating through the while loop. So let's run that, and I want to show you. So if our guess is 25, 15, 10, 12, 11. So it also exited the while loop there. So just wanted to show you that by changing our value here of our statement to keep the while loop going, changing that to false, we can end the iteration of the while loop that way as well. And the second thing, I realized that we haven't talked about what this A and B are here. You'll notice I can't change them. I'm trying to click and drag my mouse over them, but it doesn't actually do anything. It goes all the way over here once I get to another character. That just shows you that the method randint takes values A and B. So literally within this method, it assigns those values to A and B, as we saw, and PyCharm just displays that for us. So as we saw when we were at the terminal, and we did Python import random dir random, and then we did help on random.randint. Then we saw it names these A and B. So PyCharm, it just sees under the hood like that, and it knows randint names these A and B. So it's just spitting that out for us to make make it easier for us to see that so that we know. So that's what A and B is. It's not anything that we've input. They're not variables that we've input. It's what randint uses. So wanted to point that out. Okay, now we will see you in the next video.